the ACM India Industry Day at Manipal Institute of Technology, Bengaluru. This event is organized by ACM India in collaboration with the ACM Bangalore chapter, iMobile chapter, and the MITB ACM student chapter. The aim of this event is to bring industry experts, academicians, and students to explore emerging trends in computing. Industry academia collaboration plays an important role in driving innovation, and today's event is a step towards that. We are privileged to have distinguished speakers from leading organizations who will be sharing their experiences and insights. Their expertise spans areas such as data science, artificial intelligence, machine learning, blockchain, and a lot more. Today's world is evolving at an unprecedented rate, with artificial intelligence and mobile communication driving fundamental transformations across industries. From AI-powered automation and machine learning breakthroughs to next-generation mobile communication technologies and edge computing. These advancements in such fields are shaping the future of businesses and research. Before we begin, let me take a moment to recognize and express our gratitude to our host institution, Manipal Institute of Technology, and the management of Mahi Bengaluru for their unwavering support for promoting computer research and professional activities through the MIT ACM student chapter. Before we begin with the technical sessions for today, let us begin with the inauguration ceremony. First, I'd like to invite Dr. Gururaj Hechal, ACM India Eminent Speaker, former ACM Distinguished Speaker, and the faculty sponsor for the MITB ACM Student Chapter to deliver the welcome address. Dr. Gururaj has been a pillar of support for the MITB ACM Student Chapter, constantly encouraging student-led initiatives for fostering industry-academia interaction. His guidance has been instrumental in shaping this chapter to be an active platform where students can share knowledge and help in the professional development. Over to you, Dr. Gururaj. Thank you.
Very good morning to everyone present here. Respected dignitaries, my dear students. I take this privilege to welcome each and everyone for this Industry Day, ACM organized by ACM Student Chapter. First and foremost, I take this opportunity to welcome Mr. Saudya Roy, Vice President, Chief Guest of today's event. Heartily welcome you, sir. I request Dr. Prema Kivi, Associate Director, to give a samplings as a token of welcome. I take this opportunity to welcome Mr. Krishna Suryanarayan, Senior Research Engineer, IBM India Research Labs, Bengaluru. I request Dr. Prema Kivi to welcome Mr. Ram Suryanarayan. Welcome, Mr. On behalf of MITB ACM Student Chapter, I take this opportunity to welcome Dr. Amit Saha, India Site Head at Docklands AI, Chair of ACM iMobile. I request Dr. Prema Kivi to welcome Dr. Amit Saha. Thank you, ma'am. Now I request Dr. Dayananda P, Professor and Head Department of IT, to welcome Dr. Renuka Siddhagata, Senior Technical Staff Member and Manager, IBM Research, Bengaluru. I welcome you, ma'am. I take this opportunity to welcome Dr. Anbanai Punaya, sorry for the name, Chief Architect, IBM India Software Labs, Bengaluru. I welcome you, sir. We have with us Dr. Prashant Mishra, Senior Scientist at TCS Research and ACM Distinguished Speaker, who has been support for this event to organize this event meticulously for past almost a month. We are working together. I heartily welcome you, sir. I take this opportunity to welcome Dr. Dayanand Api, Professor and Head Department of Information Technology. I welcome you, sir. I should not forget to welcome Dr. Shreyas J, membership chair of ASIM Student Chapter, Assistant Professor Department of IT, MIT Bangalore. I welcome you, Dr. Shreyas. On behalf of MITB ACM Student Chapter, we have received participation from various colleges. On behalf of MITB Student Chapter, I welcome each and everyone. And now I request the Chief Guest and Associate Director to come on the stage.
Thank you, Dr. Gurraj Achal, for the welcome address. To formally inaugurate today's event, we now invite our distinguished dignitaries on stage for the lighting of the lamp. Sirs and ma'am, please join us on stage. Thank you, dignitaries. It's now the time to invite Dr. Shaurya Rai, Senior Vice President, Data Science at Zepto, and the member ACM India Executive Council to address the gathering. Dr. Shaurya Rai is a seasoned technology leader with expertise in data science, natural language processing, and machine learning. Over the past 2 decades, he has led data science and analytics teams at IBM, Xerox, American Express, and Flipkart. His contributions span foundational research, product innovation, and strategic leadership in AI-driven domains. He's also a thought leader with over 80 peer-reviewed publications and 35 graded patents. Currently at Zepto, he leads a large data science organization focusing on verticals like pricing, supply chain, trust and safety, marketplaces, fintech, and travel. Dr. Shaurya Rai, over to you. Thank you.
Good morning, everyone. Very happy to be here. It is an honor to be a part of this event and have the privilege to kickstart this wonderful industry day at the Manipal Institute of Technology. While it has been extremely impressive to come into the campus. This is the first time I'm coming here, in spite of living in Bangalore. It is one of the best campuses that I've probably seen across the country. Amazing setup. I hope I will get to spend some time, if not today, some other day, to see all the facilities and everything. But also very happy to see that the ACM student chapter at MITB is so active. I mean, while I have been to many student chapter events, and in general, student chapters are actually quite active. But I was just hearing about the Manipal student chapter, the kind of events that you do, the kind of activities that you do. It is very encouraging and very good to hear about that. As a part of the ACM India Executive Council, I would love to interact more with the student chapters here to see that okay, how the ACM Council can actually help. And maybe later in the event, I'll talk briefly about the student about ACM and what ACM does and what ACM means. And would love to look forward to interact with the student chapters as well as the other students who may not be a very active member of the student chapter to interact. And so looking forward to have a wonderful and fruitful day of interactions. Thank you.
Thank you, Dr. Shole, for that address. I would now like to invite Dr. Prema KV, Associate Director, MIT Bengaluru and Professor Head, Department of CSC. Dr. Prema KV is an ardent supporter of the MITB ACM student chapter. Her dedication to mentoring students and encouraging research initiatives has helped foster a thriving technical community at MIT Bengaluru. Over to you, Dr. Prema.
Thank you, Nishant. And as okay, our chief guest was mentioning, okay, this is a very vibrant chapter. I would like to appreciate and make you all know that the one of the okay speakers, our student Nishant, I have seen him since first semester. He has been very active and self-motivated. He would like to okay take up these chapters or clubs to enhance his learning capability. I hope that all of you are present here, the students from MIT as well as from other institutions, out of your own interest and not because somebody asked you to, okay, the coordinator, the faculty coordinator, or somebody insisted that you have to be present. I feel that okay, all of you are here out of your own interest. On behalf of CSC and IT department, as well as on behalf of MIT and MAHE, I would like to formally welcome each and everyone present here for this ACM Industry Day. So I would not like to come between you and the okay, several industry experts that we have here for this function today. I hope that all these interactions, what we are going to have now, from now onwards, will be very fruitful and there will be a lot of value addition through these interactive sessions. Once again, hearty and cordial welcome to each and everyone present here. Thank you.
Thank you, Dr. Prema, for those words. With this, we come to the conclusion of today's inaugural ceremony. I would like to thank all the students who have taken the time and effort to attend this. I would like to thank the ACM India Council for their support in organizing this event, along with the management of MAHE. I would like to also thank the collaborating chapters for today's event, ACM Bangalore chapter, along with the ACM iMobile chapter for the continuous support. I'd like to also take this opportunity to thank the dignitaries who have come out of their busy schedules to come and interact with us students here at MIT Bengaluru. I would also take this moment to thank all the students who have come from partnering ACM chapters and other institutions from in and around Bangalore for attending today's event. Thank you. We now move on to our first technical session for the ACM India Industry Day today. the keynote address by Dr. Shaurya Roy. Dr. Roy, we would like to invite you on stage for your address. Okay, for some reason the slideshow is not working. I hope if when in the normal screen the slides are visible, right? At the back row, right? Good. Okay. Okay. What I thought today I'll do is that I'll give you a quick overview about ACM India. Maybe it is known to many of you who are the active chapter members, but may not be everybody. So I thought that at least some part of the ACM, what does ACM India do and what does ACM India entail is what I'm going to talk about. So it is not a keynote in a technical sense. There are extremely rich technical content is coming on your way. So I'm sure it will be very, very informative and knowledgeable for all of you. But let's talk about ACM India as we in the next 10-15 minutes session. So what is ACM? Okay, my animation is gone. So first, the problem with slideshow is that. So if somebody does not know about ACM, right? I mean, and one of the things that we do today, if we don't know about something, we go to a generative AI agent and ask, okay, what is this, right? And that is what I did. And fortunately, what is ACM? The first answer comes actually what is the desired answer. But of course, there are many ACM that is there, right? Now, ACM is the let me just shift here. ACM stands for the Association for Computing Machinery. Right? This is an organization that had started in the year 1947. Right? One of the oldest running institutions in the technical world, uh, and it celebrated the 75th year in 2022. And not only the oldest, it is the largest educational and scientific computing society in the world. Right? Today, ACM globally has more than 150,000 members across the world. ACM has many what we known as the chapters across the world. And these chapters are of various types, and I will talk a little bit about the more about the chapters. But there are certain chapters which are geography-based chapters, right? And similarly, in India, as a geography, we have ACM India,
which got launched in 2010, right? So it is fairly recent in compared to the large history, the long history that ACM has as an organization. But in this short amount of time, ACM India has gained extreme popularity and has been doing again a whole bunch of things. And with a membership that kind of today constitutes about 10% of the total ACM member, right? So about 15,000 members are there in ACM India, and which is a growing and counting list, of which about 8,500 are professionals and rest are students, right? Now, if I look at the composition of the ACM members, so there are students and there are professionals, right? That's the clear two big sets. Of course, there are professionals who are from the academic professionals, there are industry professionals. Within industry, there are more researchy professionals than maybe applied professionals and so on and so forth. But broadly speaking, there are students and there are professionals. So everything in ACM India that we try to do are essentially catering to one or both of these, as we call, cohorts of members, right? Students and the professionals. So let's see some of the example activities. What does ACM India do for say students? This is where probably the slideshow would have helped. But here are some examples of some of the initiatives that ACM does for students. One of the first ones that is most relevant and very useful for students are the summer and winter schools. ACM India hosts a number of summer and winter schools, both in the month of about June, July, and some of the initiatives that ACM does for contemporary. One of the first ones that is most relevant and very useful for students are the summer and winter or generative AI. ACM India hosts a number of summer and winter schools, both in the month of about June, July, and some of the initiatives that ACM does for students. One of the first ones that is most relevant and very useful for students are the summer and winter or generative AI. ACM India hosts a number of summer and winter schools, both in the month of about June, July, and some of the initiatives that ACM does for students. One of the first ones that is most relevant and very useful for students are the summer and winter or generative AI. ACM India hosts a number of summer and winter schools, both in the month of about June, July, and some of the initiatives that ACM that I will be talking about. These are in very much detail are listed in ACM India website. You can just search for ACM India and you will be able to find more details, how to go about it, how to apply, what are the topics, where it's going to happen, when it will happen. All of these you will be getting, right? My idea here is to kind of tell you guys that what do they. So while summer and winter schools are primarily targeted at the undergrad and the master's students, of course, this is open for all students. There is a specific activity that ACM India has been doing over the last few years, which are known as the PhD clinics. So PhD clinics are essentially, and again in simple words, the motivation is that a lot of people a lot of students who are doing PhDs, they often would like to reach out to an expert who may not be part of the same institution to get another perspective, to get into a problem statement which is where the particular faculty member is working, or even an industrial researcher is working, right? So this is like a one-on-one mentoring outside the formal structure of the PhD program that you have. Again, you can sign up. There are a bunch of, I think about 30, 40 mentors are listed across different top ranked institutes in India. You can go there, figure out what are the areas, and actually reach out to in a very simple process by filling up a Google form and get connected with various of the mentors, right? And this could be one session, multiple sessions, virtual sessions, physical sessions. All of those are very structured. So this is again, it's a clinic where you kind of go and meet an expert and get get a get certain issues resolved, certain technical issues, certain ways of doing research, and so on and so forth. Right? Again, and there are a whole bunch of other things like Anveshan Setu, which is like an internship program, research in opportunities in computer science, which are like more activities in terms of how do you do this, what are the focus areas for research in computer science, webinars, PIC, Pingala Interactions in Community, which is our hallmark event for research progress in various computing areas, right? Again, please do check out some of these activities on the ACM India website. You will get a much better perspective. The second slide is about the activities focused on students. There is a typo on the title. This is for the activities focused on professionals, right? So as I said, that there are half of the members or about half of the members are professionals. While I do understand that probably there is not much of a professional representation here, but I just wanted to kind of quickly expose to you what are the kind of activities that ACM does through professionals, right? The first picture that you see is a new concept that ACM India introduced a few years ago called ACM India mini graphs. So mini graphs are essentially a technical area of industry and practical relevance, which is explained in simple words by industry experts. For example, hybrid cloud, blockchain technology, cloud computing, security, data science, right? Many of these, while as students, you will be getting a good perspective, in-depth perspective from your academic curriculum. What does the industry perspective look like, right? And these are like 20, 30, 40 page, very simple worded mini graphs for you to get a industry perspective. So this is an initiative that ACM India has started recently. Eminent speaker program, industry experts serve as the multiple of us are here are the eminent speakers here. So who kind of come to these talks in their different expertise. And the way has this privilege to invite, I believe, one eminent speaker every year, for which the cost is borne by the ACM organization and so on and so forth, right? So you can always invite ESPs from any part of the country by following the process and interact with them in your own campus. We have many professional chapters, six, um, boot camps. Boot camps is again a very interesting concept for the industry experts who would like to know about a different area of research, right? For example, I work in the area of data science and I want to know about quantum computing, right? Of course, there are certain ways I can learn self-learn, but ACM hosts different boot camps where the industry experts can actually register. The topic specific experts will come and essentially take a 3 day, 4 day kind of a hands-on course on various topics, right? And because of HCM's extremely big network of professionals and students, we are able to host many of these. The ACM has a special focus on diversity, and these are some of the examples of ACMW or ACM activities. For example, we have the annual celebration of the ACMW chapters. Every year this happens where there is a particular theme around which a lot of that they will be coming, and the annual celebration is hosted. We have the Lady Ada National Level Programming Contest for Women. We have Nari Yukti Tech Hack. The programming contest is more of a like a hackathon, while the tech hack is more like a conceptualization, building, and so on and so forth. Like not only the coding part of it, but also the problem solving and bringing the whole solution up. And finally, again, I know that there are student chapters that you have in your institute and in other chapters, in other institutes, but there are many different types of ACM chapters are there, right? For example, SIG professional chapters. Anybody knows what is SIG? Yes. So these are special interest groups in various topics, like stick graph, like iMobile, like stick Sky, like IKDD. So these are all the special interest group professional chapters where you can actually go and interact with the experts on the specific areas. We have professional chapters, we have student chapters, we have six student chapters. So there are multiple student chapters which are focusing on specific six areas, like six guy in IIT Kanpur, then six of in MITB. Oh, okay, I didn't know that you guys have a six of chapter. Wow, that's great. That's really great. So basically, ACM does provide this opportunity to actually not only kind of bring in a computing community, but also kind of form the chapters at a very niche area on a specific area, right? And two such professional chapters, I thought I'll just quickly introduce for which the leads and the chapter chairs are present here. One of them is the ACM Bangalore professional chapter, which is chaired by Anbu, and vice chair is Renuka. Both of them are present here, and you will be hearing from them later today. They are working on various aspects, both in terms of facilitating and collab and sharing the industry academic research. They are talking about things like industry collaboration. Like, I mean, only an entity like ACM can actually facilitate very actively industry collaboration, right? Otherwise, every company has their own boundaries in which they are working, and there is a lot of brainstorming and the thought process sharing cannot happen unless it is by a third party. The other chapter is the iMobile ACM chapter. Amit is here. Thing. So iMobile ACM chapter is one of the newest SIG chapter of the, it's an Indian version, Indian chapter of the ACM SIG Mobile. So it started in March 2019 and specifically again focusing on the mobile computing and related areas while adhering to the global charter of the ACM SIG Mobile, right? So again, telecommunication and mobile computing has been an extremely rich and energetic areas in the recent times. So if there are people who are interested in this particular domain, please again, I mean, of course, you can go and check on their website and LinkedIn, but also feel free to connect with Amit here during the breaks or today, so that you get to know that how you can contribute. And while I understand today, most of the population today here are student chapters. But one thing that I would like to request you, there are many professional chapters through which you can continue your ACM association and journey beyond the university campus. Do not do not stop your ACM association after you graduate from the college, right? Okay, so this is the fun thing that we did during the college time, and after you become professional, there is no thing. There are plenty of things that you can do and continue enriching your professional career through ACM association. So with that, I'll stop and thank you very much for your attention. Thank you, Dr. Roy, for the insightful address what ACM is and the different constituents and how students can contribute and be a part of it. I would now like to invite Dr. Gurraj Hachal, faculty sponsor MITB ACM student chapter, to felicitate Dr. Shaurya Rai. Sir, please join us on stage. Thank you, sir. We now move on to an address by Mr. Krishna Suri Narayanam, Senior Research Engineer at IBM Research Labs, Bengaluru. Mr. Krishna Suri Narayanam is the senior researcher specializing in data and AI platforms at IBM Research India. He has made significant contributions in AI-driven enterprise solutions and holds over 45 granted US patents and plays a pivotal role in IBM's blockchain and AI-based automation innovations. Today, he is going to deliver an industry talk on intro to LLMs on tabular data. We would like to invite you on stage.
Yeah, I think, sorry for the delay. We are outside. I'm told that I have about 30 minutes. So I'm going to talk about this topic, introduction to large language models and tabular data. So this gives you, I'm hoping that it will give you a flavor of both what large language models are, and in particular, what is the so much special about them working with tabular data. So first of all, are you able to hear me? Is it audible in the okay, good. So let me on the topic. Um, I don't want to, in particular, spend too much time on the large language model. What it is, probably you must be knowing much more than what probably I know. But I can specifically talk about on the aspect of LLMs for tabular data, right? So I will briefly give some background on LLMs, and I try to address during my talk three specific questions. LLMs on tabular data, what is the issue? And why LLMs struggle with tabular data? That is another question. Third one is how to make LLMs work with tabular data. So what is the issue? Why is the issue? How we are going to address? These are the three simple questions we are going to try to understand these questions, right? Answers for these questions. Right, and here is a very brief background on LLMs. LLMs are AI models that can accept natural language and also get back to humans with natural language. And LLMs are pre-trained on large corpus of data, right? And that gives them the ability to become natural fit on multiple NLP tasks with ease, right? Tasks like let's say text summarization to question answering and language translation and so on. So they are available in different sizes, varying from hundreds of millions of parameters to hundreds of billions of parameters. Right. So some of the aspects only I'm touching here, right, which probably are helpful later part of my talk. So those particular aspects. Otherwise, it's not sufficient to cover background on LLMs in one single slide. That you all know. So LLMs use deep learning, in particular transformer-based architecture. They need huge computational resources and energy, both for the training of these models and as well as for their use, that is inferencing, in both the and last but not the least, ongoing research is happening to improve their both efficiency as well as a lot of their capabilities, right? So it's still evolving. Now, let's try to see when LLMs train on unstructured data, why they will struggle with tabular data. So let's start with simple examples. Before I start, I assume that all of you are aware of what tabular data is. Tabular data is nothing but another form of text data, but it is more structured, right? It is organized in rows and columns, which we are very much familiar with. And the strange part is that even though the tables are so much familiar for humans, LLMs unfortunately struggle with understanding and reading that table. Okay. So here are few examples. By the way, all this talk is based on one of the research papers that appeared last year in ACM SIGMAD, which is the flagship conference. And I have a reference to the specific paper that I am referring to right now, right? So you can go and check that paper for more details if you wish to, right? But most of it is taken from that same paper. Now, here are a few simple examples that demonstrate the fact that LLMs actually struggle to understand tables data. So here is first example. What is saying? Now, throughout these examples, we also try to cover some table tasks similar to the NLP tasks that I just talked about. There are counterparts of those tasks when it comes to table data. Similarly, let's say text summarization using the NLP word. Now, in the tables world, you see table summarization. Similarly, there is a question answering in NLP word. Here we have table QA in the table word. Similarly, fact checking both these places and so on. Every task that you see on NLP world in the NLP world, you have a similar problem in the structured world also. Okay, and I try to go over some of these problems uh, to help you understand what these problems look like, how these problems look like when it comes to tables. Okay, so that is the main idea. So let us take this simple example of missing value identification. Okay, so to understand why LLMs struggle with the tables data. So missing value identification is a problem that's defined as below, right? Find, unfortunately, the pointer is not working. Probably I can try to tell the first bullet it is talking about missing value identification, referring to the table at the left side. The problem is find the row ID and column header of a missing cell or empty cell. So that is the simple problem. You now consider a prompt for any given LLM. The prompt for missing value identification looks like the as below in the left side box. There is an instruction which says given the table below, each row and column has a missing value. And the table is represented in the prompt as the following. Each row is encoded in row major ordering, and then within each row, columns are separated with a column. So first we start with row header, row ID, name, grade, math, art, music. Those are the column headers of this table. And the below there are two rows of this table that are represented in a serialized math score, art score, music score, and so on. Now, if you see that row 2, name, row ID, grade are available. Grade is G2. Subject is math, 99 marks. Art, you see there is no value available. It's empty. And music, there is 93 marks. If you see in the table, in the row 2, there are two, without any number, there are two columns, right? So that is the missing value. And as humans, we can easily understand if I ask this same person, given this table, which row or column has the missing value? The answer is row 2, and the column is art. The column art in row 2 is having a missing value. The cell is empty. Now, if you post the same in LLM, it is giving the answer. It's row 2, but column is music. So, which is not correct. We now try to see this. This can be because of the multiple reasons. One reason could be the LLM may not be able to understand what missing value is. So to eliminate this ambiguity, let us try with a different example. That this example, this task is column type finding. In column finding, find the column name of a given value to ensure that there is no ambiguity, right? So here instruction is given the table below, every column has the value 93. Now, as humans, I want it to be a little bit interactive. Can somebody answer the person in the right, in the down? What is the correct answer? What is the column name where you can find a value 93? Music, correct. Yeah, somebody, I got the answer from somebody. Just music is it's very simple, right? So if you see in the contents of right side table, again there are those 6 columns, and the row 2, the last value is 93, which corresponds to the column music. So ideally we expect it's very simple, but LLM is struggling. It says that the value 93 is in the column art, which is not right. And make a point that make it very clear that not every time they may fail. Right? You try with the different prompts. Sometimes they will fail. Sometimes they may still succeed. And in general, in this paper, based on the experimentation that they carried out and the models that they tried, for example, the GPT 3.5 model, which is 175B, which is a large language model, that even that model, they observed it frequently failed. More than 70% of the time it failed on such simple tasks. So this, I'm trying to establish the fact that LLMs struggle with structured data. They struggle with understanding, though they are exceptionally well on NLP tasks, they cannot understand. Okay. Here are a few other examples. Again, I am trying to take these different examples to introduce you to two different things. One is the significance of the problem. The second thing is also to give you the flavor of what different table tasks look like. So this is the third table task, table question answering. What is this task? Answer a null question based on the content of a given table. Okay, so in this case, instruction is how many second graders um, second over 90 in art in the table below. Please respond using JSON answer. Uh, Something in the format, right? JSON format answer. How many second graders scored over 90 in art? Okay, so um, here fortunately, we have the marks from for students which all belong to grade 2, right? So we can count just every row. Where art has a value above 90, right? So under the, you can see that. So if you observe this input data, one point is very clear. Again, one value is missing. For row 2, the art under the art column, the value is missing. So given this value is missing, the only row that qualifies for this counting is only row 1, because the row 1 art value is how much? 94. Okay, so there is only one row where a student got for art subject above 90. But see what the LLM answered. It said answer is true. Why? Because of its ignorance of the fact that the value for art is missing. So it considered the value 93 that ideally should belong for the column music as the value for art. So it counted both row 1 and row 2 are eligible for this, and the answer is two, which is not. And there is another fourth example, data imputation. What data imputation means, given a table and certain value, the values are in certain cells may be missing. The task here is, can you actually impute or predict the values in those missing sets? So that is data imputation. It is again very popular NLP task as well. Now you can see the table is provided and the missing value is now marked as to fill. And the instruction clearly says, can you predict the missing value which is represented using to fill? And the model in this case would predict saying that yes, the answer is Asia, because if you see there is certain semantics for the table data. What semantics here means, the columns, if you see, there are two columns in particular, country and continent. Now, when country is USA, continent is America, country is China, continent is, right? So there is certain semantics associated with these columns, and using this semantics, even though the cell that is the entire continent is missing, with the knowledge that is available with the LLMs, they can predict very accurately the missing value. So this I'm just giving as an example of the fact that sometimes they can succeed. Even with the data imputation tasks, they can measurably fail. I have an example later on, which is a little bit hotter variation of data imputation task, where you can see for humans it may look like it's very easy task, but LLMs they really struggle to the core to answer those problems. We will see that later. So essentially, we have still now established the fact that LLMs struggle with structured data. All of you agree? Okay. So now we ask this question: what is the formula? Language models retain large corpus of text data. They struggle to read tables. How to? So the question we want to ask is how to enhance language models' ability to understand tables and perform table tasks. Eventually, we want to ensure LLMs are helpful for table tasks also. So how do you achieve this goal? So that is the question we want to ask. Now, before proceeding toward how we achieve that, accomplish that goal, let us ask why the first place this problem is arising. Right? The main reason is that LLMs are trained, as I mentioned, with large corpus of text data, And when it comes to tables, there are certain differences between these data formats. So that is the root cause of these problems. To call out some of the problems or differences that are causing this issue, NLP texts are one-directional in nature. That is, we read from left to right, and we process them token by token in a sequential manner. Okay? So also swapping the tokens usually changes the meaning of that particular sentence. For example, Alice and Bob, if I swap Alice and Bob, Bob helped Alice. They both are not same, right? One first says Alice has helped Bob, other says vice versa, right? So changing this sequence really, in most of the times, causes difference in the meaning. Whereas, if you consider the relational table, they are typically two-dimensional, right? As against to text data, which is one-dimensional, they are typically two-dimensional, which also means that the data is organized in the form of rows and columns. And these are read from top to bottom. Whereas one-directional text data, we read from left to right. This is typically processed row by row. That as humans, we do that. We go over the first row, over the different columns, and then go to the second row and so on. So read top to bottom in vertical direction. And corresponding to a particular column, we process them from again top to bottom in vertical direction. And the column pairs consist of semantic relationships, as I just explained in the country and continent example. If you consider different pairs of columns in a table, they do have most of the time some semantic relation, right? So it is very essential to understand what that meaning is in order to efficiently process any table task, right? So which is obviously missing for the vanilla LLMs unless they are tried with table data. Next, tables are largely invariant to row column permutations. We saw that text, if the token ordering is swapped, the meaning completely changes. On the other hand, in tables, you have two rows, row 1 and row 2. You present them in any order, row 1 first, row 2 second, or vice versa, row 2 first, row 1 second, really doesn't change. For example, what is average marks in the student's table? Either you consider 95, 97, average is 96, or 97, 95, average is 96. Here it doesn't matter. The response is the same. So similarly, columns. You first have continent column, then country column, or vice versa. There is not much difference, right? So these are some of the important distinctions between one-dimensional text data and two-dimensional table data. But there are a few other examples also which are contributing to the fact that unless you train the LLMs with table-specific data, they will struggle to work with tables. Any questions so far? Okay, then we will now move towards how we address this, right? Yeah, sure.
So what about hybrid approaches which involve LM or
Yeah, definitely. I think a lot of these problems were addressed using traditional AI/ML techniques, right? So, in particular, we are trying to address these problems in the context of LLMs. Okay? And I started with the fact that LLMs, the vanilla LLMs, which are typically trained with text data, so they struggle to work with these tasks. But if you consider nowadays, a lot of these LLMs are have seen the structured data also, so they may not fail so badly. But for some tasks, it is still required that we need to fine tune those LLMs also, which have already seen table data. Still, we have to fine tune them or extended pre-train them with table specific task. So it's all about this particular task. But that's the relevant question. Any other questions? Okay, so we are now trying to address the how we can actually address this problem, right? And there is an analogy that we can um, draw here between how such problems are addressed with LLMs with regular text data versus LLMs with table data, right? So in the text world, NLP world, this is addressed using multiple different techniques. One of the technique is instruction tuning. What instruction tuning means is, um, for example, before that, what instruction tuning, why instruction tuning in NLP is required, let us see. Okay, without instruction tuning, language models may fail to understand certain human instructions. For example, write a bedtime story, which is a very easy instruction there, which can be most of the times processed by any LLM. On the other hand, if we ask write a bedtime story about a bear for a 3-year-old in 100 words, if we ask in more hierarchical manner, a little bit complicated, some of the LLMs may fail because this instruction itself is lengthier and there are multiple parts to it and so on. So to make the LLMs be able to understand such complex human instructions, this technique known as instruction tuning is adapted in NLP world. What it is, you will see the left side. Um, we consider the past researchers used to consider these pairs of data. One is instruction, another one is called completion. Instruction and completion pairs for different instructions and completions. For example, instruction says that write a bedtime story, right, and completion it will be actually few lines of story, right? So similarly, another instruction. Can you give me an instruction about how to prepare some particular recipe and so on? The answer, how actually I expect the response from the LLM should look like, right? So those instructions and the expected answers from the responses from the LLM. So they are called completions. So those two pairs are created manually for a variety of instructions and shown to the LLM so that now they can generalize to new instructions without much training, without much trouble. So that is the usual practice with LLMs for text data. Now let's see the counterpart when it comes to tables, right? Similar stuff, but we also need to provide the table in addition. So there is it's a triplet now. Instead of a pair, you have to show multiple instruction, table, and completion pairs. Instruction is as simple as can you compute the missing value, and table is as good as any one of our previous example table content, and the completion is expected answer. For example, if I say in this example, what is the to fill value, the answer. So here the data interpretation task, this right hand side, it qualifies as one instruction table and completion table. Okay? You come up with multiple such instruction table and completion pairs and show it to the LLM so that it is now aware what a table task looks like, and it can build that understanding. Right? So it's very simple in that sense, but of course complex, as you know, right? So this is one popular technique to make LLMs work with table data. There is another, okay, benefits of train are, this can be done at two places, right? At the pre-train time as well as at fine-tune time. Okay, so at the pre-train time, probably you show such triplets that corresponds to multiple different tasks, right? So that the LLMs after training can be generalized to a wide variety of table tasks. So that is one objective. Second thing is you can do it at a fine-tune level. That means you know this is my particular task that the LLM should be able to help me, and let me only come up with the training data covering only this particular task type and throw to the LLM to train it to work in this scenario. Okay, so here I am talking about something called generalizability. What is generalizability? So generalizability in general means that once you pre-train and fine-tune your model without additional work from your side, that is without additional training, it should you expect that the model adapts to new problems and new tasks. So for example here, column type annotation. This is consider this example to demonstrate the fact generalizability to new data sets. So assume that you have shown at the training time column type annotation with let's say 78 types to choose from. This problem is given a set of values under a column, you ask this question, can you predict what these values under this column, uh, what is the data type associated with these values under this column. So for example, this is the table, column 1, and Apple, Microsoft, IBM, let's say. So what they correspond to, can you anybody guess? From the candidate 28 types. If you want to choose their companies, their celebrities, and so on, what do you say? They represent companies, right? So, so that is column type annotation task. Now, the problem is general data set generalizability is, let's say, I ask similar question next time with instead of 78 candidate options to choose from, let's say 120 options are there whether my model is able to answer in such a scenario or it is going to fail. Ideally, I expect it adapts to such scenario also. So that is called generalizability to new data set. Now, second variation of generalizability is generalizability to new tasks altogether. You see the right side example, right? You are asking, okay, so instructions says please set the paragraphs below and extract facts from the text to produce a structured table. So we said Washington is a state in Pacific Northwest where the capital is Olympia and so on. Mississippi is a state in the south, southern US and so on, right? So we are saying providing some text data and we are asking the LLM to represent the same text data in a table format. And this task was not shown to the LLM at the time of either fine tune or pre-time, right? Still, the LLM is capable of answering properly, come up with the table. So this is called generalizability to new task. So because you trained the LLM with a wide variety of task specific data, it now has a better understanding of what tables are, how to read them, what they, what some of the typical questions or tasks on tables means. It can generalize. So even though you don't need to specifically train them with such tasks. Okay, so these are the two benefits: generalizability to new data sets and generalizability to new tasks that we ideally want to achieve by means of pre-training and fine tuning. So this is one way. Another way is also possible that is known as prompt engineering. You already might be aware a lot about prompt engineering. So there are techniques like zero shot prompting and few shot learning techniques. Essentially, the prompt engineering is kind of, I would say, restricted in terms of it is a task specific typically. Whereas fine tuning and pre-training, they can work for across tasks. Prompt engineering is more like you want to achieve this task. Probably you say you store different data sets and different instructions and their respective completions. You expect that this would help the model perform well with a similar task on a new data set, right? So that is the expectation. And why I'm calling about prompt engineering is that while prompt engineering is a very popular mechanism to get sort of your LLMs, prompt engineering can also be coupled with fine tuning and pre-training, right? So the same holds good even with table tasks. Okay. Probably, okay. Time check, how much time I have? 10 minutes. Okay. So I have two more slides, which are little bit shifting gears towards complexity, and we'll try to cover them, and I will close the session. So far, so good. Any questions? Okay. So till now, we kind of established what are the issues with the LLMs with the table data, why those issues are primarily arising from, and how to overcome those issues. So all the three goals we are kind of method. Here they are going to do something little bit advanced. So let us see challenging table tasks. As I mentioned, missing value, a variation of missing value imputation task we have seen. We will see two little bit of complex variations of the same problem. Missing value with column separators. Let's say in the left side you can see in the table we have 3 rows, and one value is missing, which is highlighted using red color there. Okay, and here again the instruction is the same, the question is the same. In the table below, which row ID or column contains a missing value? We wanted to ask this simple question, right? As humans, we can easily tell most of the times that row 2 is having a cell with missing value, as well as the column continent is having a cell with missing value, right? So now, a variation of this problem is you feed similar data, but without the column separator for the missing value. That is the right side. This is a little bit complicated, but still we will see how human brain can process this and answer it. For example, again, continent is missing, but still immediately we have some number. By looking at this table, what we can realize, my columns are row ID, country, continent, and GDP. So GDP is a number column. So when for the row 2, the right side, I see that row 2 and China and immediately some number. Okay, so China is probably the cell that corresponds to country, and there is a number immediately. So I don't expect that number corresponds to the cell value under continent, right? As a human, we expect some text data, and it is most likely should be the cell value for GDP. Given I see the above rows, below rows cell values under that column, this number is more looking like this value should be under GDP. Now, if I ask what is the continent for row 2, I can tell with this simple logical reasoning that value is missing. Okay. But when you see the same is presented to LLMs, even those which are instruction tuned, and even those which are probably prompt engineered with a lot of examples to accomplish this task, they fail to answer most of the cases. And they have in particular conducted this experiment, and these are some of the results. They did this experimentation with more than 1,000 samples, and how these are the results, right? You see, the model used is GPT 3.0, 3.5 with 0 shot. For the task on the left side, that is find the column header test, right? With no column separator and with column separator. You can see um, 0.26. It says that when there is no column separator, there are two problems, right? We found out that row identification and column identification. Can you anybody tell which is the more difficult problem? Identify when I provided you with a missing cell, okay, a missing value cell. Identifying which row the value is missing is difficult, or identifying which column the value is missing is difficult. Can somebody answer? Column is difficult, exactly. Row is much easier. See, in the, both the cases, directly by looking at the red, of course, red won't be there when we are provided with the data, but easily we can make out row to row two in both the examples. But to identify whether the cell belongs to continent or country or GDP, you need to spend some time, right? You have to process the data and identify, oh, okay, so this corresponds to continent. So identifying which column the cell value is missing is difficult for humans. The same is good for computers also, right? Machines. Okay. So that's the point here we wanted to make out. So if you see find the row is the performance is better around the business. But surprising part is we may think that identifying the row ID is so easy for me as a human, but computers LLMs fail. and the performance is about less than 80% most of the times. Even with the few short examples, that is with prompt engineering, and under um, the column separators present, the best performance they could achieve is 0.91. Okay, so the worst case is the diagonal 1.26. That is no few short examples provided, and you are identifying column headers, and there is no separator. In this combination, that is the hardest problem. You are provided with no column separators, and your task is identifying column, not row, no column separator, and there are no few short examples. Under these scenarios, LLM fails the most. Okay, so these are some of the instances of difficult problems, but there are much more difficult problems as well. That LLMs, even after training with table data, so they fail. And this training with table data is known as table tuning, similar to instruction tuning. They call it as table tuning. So what is the problem? What is the solution for it, right? Um, Hopefully for every problem there is a solution, and there is a solution for this too. And the solution is you have to provide some additional information as part of your triplets. We have seen that we train with these triplets: instruction, table, and completion. Now, the additional information we are providing here as part of the completion is don't just give the expected answer, but also provide some reasoning why that answer is expected. So this is the additional detail. Okay, if you feed the LLM with these multiple instances of these triplets, where the completion, in addition to the expected answer, also consists of the reasoning why this answer is expected. For example, error detection task. Error detection is as simple as misspelling to anything else, right? Error spell value, you expect it has to be Delhi, capital of India, Delhi, but it is written as, let's say, Hyderabad. Okay, so that is an error. Sometimes it can be Delhi itself, instead DLHA, they might have say DEHA, L is missing. So multiple different types of errors are possible, right? I don't want to go deeper into that. This particular problem itself is very complex, but consider a very simple thing where missing spelling mistakes are present. So here, please examine the table below and check which cell may be misspelled. If there are no erroneous cells, the instruction says that return me answer none. If there are erroneous cells, return the answer in the form of a JSON, where answer is so and so. So table is given, and um, the question is given, MISSI, SIPI, right? The correct answer is Mississippi. Um, the row to the state, that is the cell with uh, erroneous value. And what is the error with that cell value? There is a spelling mistake. Okay, Mississippi is wrongly spelled. Okay, ideally, the model, right, it may think that probably this is a city. Okay, it may be very silent and saying that okay, there is no error in this content provided. But if somebody really looks a little bit deeper, they can really understand there is no city called Mississippi with that spelling. Ideally, it should have been Mississippi, where double S needs to be there. So the additional information or reasoning is the cell Mississippi is misspelled and should be corrected as Mississippi. Therefore, the answer is this one. So this is how we fit the triplet. Another example is entity matching. Entity matching says that given I have two tables and different rows, can you actually see whether one row from one table can be related to a different row in a different table? So that is called entity matching problem. Again, it's one of the very popular table tasks. And here we are presented with this different row 1 and row 2. Each row has the same column headers: brand, model, price, and description. So can you guys tell whether these two row values are same? No, no, because the brand is same Apple, model is differing, right? And also the price is also different. Hence, these two roles doesn't correspond to same entity. So we can say that the first and second products are likely different because they have different prices, because their prices are different. So this can be additional reasoning information that we can provide along with the completion. Right. So these are some examples how to deal with the difficult table tasks. And yeah, so this is there are two references. In particular, most of this talk content is based out of the first reference, but I also would recommend, if time permits, you take a look at the second reference also. It's worth spending time there. With that, probably I will complete.
Question for the audience. What are the key takeaways from this talk? That's point number one. Point number two. Examples. What are the type of rock? And how do you call that rock? What are the guys in the back? Did you get anything from the talk? Key takeaways from the talk? Last row? Perfect. Very good answer. Yeah. Anything else? Okay, final point. Final takeaway from this talk. You table tuning. So the last row is completely blank. Okay. So see, these talks, we are doing it for you, it's not for us. Okay. So be attentive. And because I'm going to repeat these questions again after the next talk. Okay. So be very attentive and look for what we can ask the question for. Okay. It's not for us, for you. Okay. So be attentive to the talk.
So, thank you. Thank you. Jason. I would like to thank for the organizers and providing me this opportunity. It's really my honor to be present and be part of this event today, and looking forward for more interaction in the future. Thank you.
Thank you, Mr. Narayan, for that insightful address. We would like to invite Dr. Guna Fetchel, faculty sponsor of MITB ACM Student Chapter, to felicitate him. Please join us on stage.
Please give them a background of applause.
we move on to the next address, we have Dr. Amit Saha here with us, who is the India site head for DocLens.ai and is also the chair for the ACM iMobile chapter. Dr. Amit Saha is a leading expert in mobile computing and AI applications. And as the chair of ACM iMobile, he plays a crucial role in advancing research and industry engagement in mobile systems, AI, and networking. Over to you, sir.
Running a bit late, so I'll try to be quick, but please interrupt me with questions. Um, so why mobile communication? So a question to get people started. Today, if right now, if the power goes on in this auditorium, will you be more interrupted? I mean, I would be more interrupted, or would you be more worried if the network goes away? Which one is more important for you? Power or network? Right? Also, most of it. What is the device that stays, what is the thing or device that stays closest to you more than any personal relationship or anything at all times? Right. I think mobile is the only thing that spends time with you even in the bathroom, right? Nothing else spends time with you in the bathroom. So that's why mobile communication is very, very important. I think most of you have grown up in the mobile generation. You have not seen non-mobile communication at all. Um, Maybe some of you, but most of you shouldn't have. So that is the reason that this thing is very important, and I have spent quite a bit of time in this area. Though right now I don't spend time in this area, but irrespective of that, I wanted to give you an overview of where mobile communication is expected to go in the next 10 to 15 years. However, when we talk about anything that is coming up in the future, we always have a problem of not knowing where we came from, right? So those who cannot remember the past are condemned to repeat it, right? So I wanted to give a overview of where we came from and then what that will lead up to what we can expect in the next decade or so. Okay. So my talk is going to focus on practically this part of your mobile, right? And specifically on the right corner where you have a cell phone marker as well as a Wi-Fi marker. These are the only two things that usually matter to anybody using a phone. Everything else is secondary, right? At this point. So first on the cell phone market, right? So this is the generation one. Nobody, I don't think any of you, at least the student community here, were alive for the generation one. We were students at that time. So the generation one, the device looked like this. It's pretty heavy. It can work as a dumbbell for most of us. And it was in the year around 1991. So around the 1980s, early 90s is when it was, right? It was primarily it was an analog system. So it was not a digital system. And there was practically no concept of bandwidth or anything. If you can make a call, that's good enough. Still, the most common way of making calls was via wired telephone. Then comes the second generation of devices, again along the same times, around the early 90s. That's when the standards, some of which are still alive, such as GSM, GPRS, Edge, this kind of technology started, and fundamentally the shift happened from analog to digital. Right? Bandwidth was still pretty pathetic. It was narrow band. You can't be probably even WhatsApp is not something that you would be able to do properly. And data rates were in the kilobits per second, right? So again, pretty pathetic by today's standard. Devices had started to become a little smaller. They were more manageable. Current jeans pockets probably will not fit them, but you could carry a handbag and carry it. And especially in India, 2G devices were a kind of, it was not really a status symbol, it was actually looked down upon. I have several stories where people carry cell phones to hide them because it gives out your wealth or your snobbishness because you're carrying a mobile. Then comes 3G. So practically 10 years after, right? Early 1900s to early 2000s. Again, some standards change. You're free to look up the standards. Basically, different ways of using the spectrum so that you are able to get better bandwidth. So bandwidth becomes broadband. So broadband means anything in the Mbps range, right? That is the typical term for broadband. And again, technology is obviously digital, and your first smartphones come into the picture. What's the biggest difference between a smartphone and the previous phone is that you don't have any physical buttons to dial. Um, I have a very nice, even with cell phones, it's a very interesting difference between how you use the old school wired telephone, which is still DTMF. DTMF means the digital versions of it, not the ones where you use the rotary one. There are very nice videos on YouTube where people this generation are given rotary phones and they can't figure out what device to bring. But the ones with the keypad, right? So I had my professor from my undergrad. I was studying in the US. He visited his son, who was my batchmate as well, and he wanted to call a friend of his. When he wanted to call a friend of his, we gave him our cell phone. He dialed the number, and then for a few minutes he said nothing is working. I don't get a ringtone, and then he said, "Did you press the call button?" And he said, "What is a call button?" Because there was no concept of a call button when there was wired. You just dial the number, and the moment you dial the 10-digit number, it would already ring. So a person who had taught us computer science, couldn't even figure out that there needs to be a call button, right? And these days, that is how we actually use the phone. So these are generational differences. And then came the smartphone. So the reason that the smartphone and especially iPhone became so popular was that it got rid of all the buttons. For every problem, you had one single button at the bottom. This was the first generation of iPhone. And the technology is 3G. Interestingly, other applications started, SMS, internet services, video calls, and mobile TV. These kind of services started in the early 2000s. Probably most of you were born around that time. Then came 4G, which is still the most prevalent technology that we're using. Came in the early 2010s, right? Technologies such as LTE, LTE Advanced. You get higher and higher bandwidth. You can get one HD movie in around under 10 minutes, which is a big improvement. People start gaming on the platform, and um, um, interestingly, cloud computing has taken up by the tech now. So there are always the mobile evolution has not happened just by itself, right? Because of the capability of your mobile devices, now you have a pretty much very powerful computer in your hand. And once you provide it to the network, you do need bigger computing resources. And that's where cloud computing comes in. That we pool resources somewhere where people from all over the world can access. So whether you're accessing email or whether you're trying to play an online game, everything kind of stays in the game and we try to offload only the bare minimum to the edge device. And finally comes 5G. Now, there's a big difference when you move from 4G to 5G. 5G fundamentally is still 4G fundamentally the communication using phone is primarily for human to human interaction or for human to machine such as playing games. Right? Even there is possibly another human that you're playing with. 5G is a fundamental difference because in 5G what happens is predominant communication is between machines. So it is M to M communication, machine to machine communication. How machine to machine communication? Because of IoT devices and practically every new equipment that you have these days is now connected to the internet. Right? Whether you buy a washing machine, whether you buy a dishwasher, whether you buy any equipment, like most of our homes are covered with multiple TVs, each of which is connected to the network. Most of us are not even, I don't think any of us are watching terrestrial TV at all. We might be watching cable TV or coming by a dish. Otherwise, most of us are watching OTT. And in this audience, I am willing to bet that most of you don't watch television at all. And most of you are consuming your media on the phone. So the phone has become everything, and there is a lot of mobile to mobile, machine to machine communication. So 5G is all about um, there is a lot of and with the network becoming stronger and stronger, there is some very important thing coming along is that emergency services are also expected on mobile companies. Right? So, for example, if you call the police with your landline phone, right, the police immediately knows where you are located. If you call the police with your cell phone, it is very difficult for the police to know where you are located. Right? So now cell phone providers have had to provide location services so that the emergency services can be provided. You, if suddenly I ask exactly where you are, it's going to be very difficult for you to identify, especially in an emergency situation. So we have gone through kind of the history of the first part of it, which is the mobile communication. Now, another kind of competing technology, or I would say complementary technology, is the Wi-Fi technology. Most of you, at least whenever you're using your mobile phones, when you really want to do something bandwidth heavy, you are looking for a like a Wi-Fi hotspot more than your network connection. Right? Without Wi-Fi hotspot, our networks are still not capable of doing kind of HD content without any glitch, or even making voice calls without a glitch. Right? So where did Wi-Fi start? The Wi-Fi kind of formally started a little later, around a decade back, around a decade later than the telephony services, the mobile telephony. So around the end of 1999, right? Around the end of the 1990s. So that was the Wi-Fi one. And data rates were already pretty high. Wi-Fi started off with like around 10 Mbps of data. And this was the 2.4 gigahertz band. We still use the 2.4 gigahertz band. And it was called Wi-Fi 11B. Then came 11G, and around another 4 5 years later, Wi-Fi 2. The data rate jumped immediately from around 10 Mbps to around 50 Mbps. How does it jump? It's the same. If you look at it, the channel width or is the same 20 megahertz channel. So basically, better modulation techniques. Right? So that allows efficient use of the same spectrum, same frequency band. Again, 2.4 gigahertz band. So 11 gig. This is 11G. Right? Then comes 54 Mbps, but in a different band, 5 gigahertz band. So earlier was 2.4 gigahertz band, but this is K/G. So K is 5 gigahertz band. Why 5 gigahertz band? Because 2.4 gigahertz band was getting too crowded and the microwaves running there. Microwaves immediately killed down Wi-Fi. So earlier, when you were using Wi-Fi and you were close to a microwave trying to heat up your lunch while using your phone, it would immediately die. Right? As in the connection would fall immediately. Right? There is just no question. It's like a jamming. So that's why the 5 gigahertz started. And 5 gigahertz has better kind of line of sight connection, but 2.5 or 4 gigahertz still works better if you're going across. These days, most equipment you'll buy will have 5 gigahertz enabled. Slightly cheaper phones might not have 5 gigahertz. Then came in 2009. So look at the jump in Wi-Fi. 99 to 2009, we have gone from 10 Mbps to 600 Mbps, right? So that's a huge jump. Why is this jump happening? Even though cell phones are being pushed by the cell phone providers who are among the bigger companies in the corporates in the world, right? Your AT&Ts and even in India, your Airtels and whatever, right? They are the people who are actually making money, whereas Wi-Fi is completely free. Nobody is charging you for Wi-Fi access except for the people who are selling in the equipment, right? So nobody is charging you. Wi-Fi is it's free. So why is can anybody tell me why Wi-Fi went from 10 Mbps to 600 Mbps in a matter of 10 years? Any idea? Pick up. No need for the mic. One time. Pick up. What content?
Intercontinental message passing. Like, countries started to develop, so more data started to flow in and more bandwidth to support the data flow.
Yeah, so good point. One thing is that the content started increasing, so people are watching more content. So there was a natural drive of pushing this in the thing. But fundamentally, what is different between Wi-Fi and non-Wi-Fi or your mobile communication? So Wi-Fi is typically a single hop, right? You don't care about the rest of it. Whereas for your mobile communication, what you need to care is the whole city, right? At least a city-wide infrastructure. Any idea what is the costliest part of a mobile communication? Say what does Airtel spend the most on? Apart from bidding on spectrum, which these days have gone crazy, right? Like you're paying billions of dollars just for spectrum. But otherwise, for running a mobile network, what is their biggest cost? Optic cables, right? Towers. What about towers? Almost there. Anybody else? Setting up 5G antennas at the base station or at your home? At the base station, okay. Anything else? So the closest answer is actually towers. The reason is not it's because you need more and more towers, but the towers are never almost owned by the service provider. The towers are rental facilities. So you have to pay huge amount of rent. So if I can now sell my house as a tower if Airtel so want, and I can charge because Airtel is worried about the complaints that is getting that my area doesn't have coverage, it's going to pay me a lot of money if I allow a tower there. Whether I should or not, because it's a high EMF zone, whether I should or not, there are health hazards and all, okay? And government wouldn't just let anybody raise a tower, but these towers are getting more and more congested, so people are willing to pay a huge amount of money just to get into the tower space. So it's rental. Basically, it's the same as why property prices go up and why rentals. So this is huge for them, and this is primarily the reason that unless a lot of people complain, they are not going to fix the problem because it's just not economical for them to fix the problem for two people who are complaining about their connection. The only way to fix that connection is to kind of have another hotspot, another spot. So what did they do? If you realize these days, most of the time that you use the Airtel in your home to make a phone call, it is actually routing it through your Wi-Fi network. It doesn't route it through your network because cell phone connectivity inside your homes in most of Bangalore is primarily pathetic. It's pretty bad. So if you switch off your Wi-Fi, you will not be able to make calls. So they have started using Wi-Fi to go make their telephone. So Wi-Fi, interestingly, has gone from 10 to 600 Mbps in the span of 10 years, even though it is free, practically driven by researchers from academia and also researchers from industry. And the primary push has been that it's a slightly easier problem because it's a one-hop problem that we're trying to solve. And also, the content viewing has pushed the demand. Right? Voice calls and all are not the most bandwidth intensive usage pattern, whereas HD like Netflix and YouTube are going to trend. Finally, we are already in Wi-Fi 5 2013. Again, not like 10 years back, 11 AC. So if you go to buy an equipment these days, you will get mostly 11 AC and what has primarily changed? Previous one as well, right? So here there is one big distinction. How did we suddenly go from like sudden jump in bandwidth is because of the antenna technology. Right? So it's a 4x4 MIMO. People who are knowledgeable about electrical engineering would understand that it's a multiple input, multiple output antenna. So one antenna instead of one connection, it can do multiple connections. Right? So that is the reason that suddenly we are seeing huge improvements in bandwidth. And there are even more increases now. In 2013, it is 7 Gbps max, right? From 600 Mbps to 7 Gbps. So Wi-Fi is making leaps every 5 years, which is like orders of magnitude faster. Again, here the 160 megahertz, 80 megahertz, a lot of channel related, spectrum related efficiency, different types of antennas, different types of modulation techniques. All of these are the things that you will actually learn if you go to an electronics engineering or an electrical engineering course. So when you are going through all of this, then you realize that what is the impact of these in the daily lives of yourself as well as everybody in the world. When you look at a QOM modulation, it is going to be one of the toughest things that you'll ever do. But you should have that perspective why you are learning this. Because tomorrow, and I'll come to this, the next 10 years, vision for the next years aren't going to be possible unless the current generation of students and researchers work on those technologies. And it's not going to come just by, just as I say, you didn't invent a car by making a faster horse, right? If we used to use horses earlier, you cannot make a car by making a horse faster or faster. You need fundamentally different technology. So and now there is a plethora of new things, Wi-Fi 6, which is still very newish. I would say it's not really available everywhere. If you want to buy something, you do a Google search. Every seller will try to push you with Wi-Fi 6 because that is the costliest device that they're selling. And so you can pay a premium to get it, but you really do not need it with current content. Then Wi-Fi 6E, which is basically using, it's a augmentation on 6. I'm not going to go into the details because all of these terms that are in the green are, except for the data rates, uh, are pretty heavy in communication theory. So each of them is a semester-wide course just to understand what's happening between these two things. And then finally, you have Wi-Fi 7, right? So Wi-Fi 7 is 2024. It has come out. It is coming out, something like that. Don't pay too much attention to the dates of the future because they might vary by 5, 10 years often without uh, yeah, it's pretty normal for it to vary. By the way, this data is from 2023, I think. So that's why till 2024 there are dashes, right? As if it is future. This particular chart is by Cisco, where I used to work till a year back, and Cisco is obviously one of the companies in the forefront of Wi-Fi. So 25 years of constant evolution with faster speed than density. Um, just a view about in 2023 itself, the blue bar, which is machine to machine communication, already dominates the bulk of the communication. Right? The green bar is smartphone. Okay? Everything else is like tablets, PCs, TVs, all this kind of things, right? So the machine to machine communication has already started dominating, which is billions, like this is number of devices. So there are way more devices using the network than smartphone, even though our view is very smartphone view. Um, Connections, again, the blue is in the machine to machine connection, what is the majority connection? Again, the blue here refers to connected home. So most of the communication is happening within our home, within our homes, and maybe within and connected work is actually a little less than connected. If you study internet traffic, what do you think is the highest time in the day when the internet traffic is high? And during the day, night time, anything else? What specifically? What around what night time? Huh? Evening, 9 to 10. Any logic why you are saying 9 to 10? So basically, at the time when people are watching Netflix, right? So Netflix and YouTube and all this like very heavy HD content, right? That's when we are watching. So most of our traffic is dominated by these, to the point that now all these service providers are saying that asking Netflix and these content providers to give them part of their revenue, right? Because you were using my plumbing to get to the thing and charging so much money and making profit, but the people who are making the plumbing or the networks are not in great financial condition, right? So there is a lot of tussle going on at that level as well. Remember, there was a time when Facebook wanted to give free internet in India. So that was there is nothing free, right? They are just going to give free internet and a free Facebook connection and then charge you for whatever content they are doing. Right? So that's what it. The nice thing was that the Indian government and bureaucrats and whoever was in charge of doing all of these things thought through it and didn't allow it. So again, connected home is big. It is going to stay big because in the next 10 years, I don't think brick and mortar offices are going to survive. We will not, if the technology landscape goes as we predict, we are not going to be going into an office, at least not regularly to do our work. There will not be any reason to do that. Many companies are already like that, but it is going to be the de facto maybe in a decade. By the time you guys are in your mid career, I don't think anybody of you would want to go to office other than to actually chat with. Right? Nobody's going to do work in the office except for like physical work. Like if you need to be in a lab, you need to be in a lab. But even that might get changed. I'm not going to this. It's going to take too much time. It just says that most of the 5G connections are kind of picking up, the blue and the orange, blue and the orange lines. The others are coming down. Application requirements. The requirement for our future, right? And future might already be here. So application requirement in Mbps. Ultra high definition virtual reality is 500 megabits per second. Okay. So this we are talking about UHD VR means you have like VR goggles or something and you are able to attend this, and when you turn around you see the person who is beside you, even though everybody is in your dorm room or wherever you want, right? You want to do that. I am speaking from my home and this view is still there. We might even do a virtual lamp lighting and everything should feel almost exactly the same. Whether it's going to be good for us psychologically or not, I have no comments about that because we as humans have probably not evolved to have virtual relationships. However, that is the requirement of the technology that is coming in. And that ultra HD virtual reality, HD virtual reality itself is around 150 to 200 Mbps, right? So this is huge demand. We are not there yet at all. With 5G, our expectations are that the peak throughput that we are going to get, or peak data rates are around 600 Mbps. Now 600 Mbps is not going to cut it if your UHD requirement is already at 600 Mbps. Right? Because everybody is going to want to use it. You can't say that only few people are going to use it. So is this doom and gloom? Of course not. There is never doom and gloom. That is why networking engineers are still working, and that's why people are still teaching electronics engineering and all kinds of all kinds of stuff. So 6G is already in the works. There is no proper standard for 6G. So now we are coming into the future of the network part, future of the mobile communication. So if you look at 6G, the user experience, like if you look at the top one, user experience data rate is around 1 Gbps, right? Everybody of you will get 1 Gbps. That's the problem, right? Um, Peak data rate is around 1000 Gbps. 1000 Gbps is the peak data rate. That is for basically a kind of a cell in your cell phone network. Uh, Reliability has to increase tremendously. We are at 5G, our reliability, 5G is the inside lighter blue thing. So 5G, our reliability is 10 to the minus 5, and which means I think some error once every 10 to the power 5, right? 1 by 10 to the 5. And then reliability it has to increase by 2 orders of magnitude for virtual reality and things to work like that. We can have the fastest network, but if it's always dropping something very erratically, right? We can't really use it for many mission critical problems. Connection density 10 to the power 7 devices per square kilometer. It's a huge number of devices. Obviously, there are not that many people in a square kilometer. There are going to be devices per square kilometer. For example, each of these chairs could have a IP address. I don't know, they might already, I'm not sure. Each of these chairs could have an IP address so that you know when a chair is broken, you don't have to come and check. Latency of your communication has to go down significantly from 1 millisecond to 0.1 millisecond. Spectral efficiency, again, how even a particular bandwidth, how well are you able to use it, has to be at least doubled. And energy efficiency also has to be at least doubled. So these are all the requirements, kind of high level requirements that we have just to make 6G work, right? And there is already discussion about 7G, which is another order of magnitude better than 6G. So what are we going to see in the next few years, right? Most of you probably have heard about this thing. There are a lot of these kind of initiatives that your institute has already started taking. So for you, it might not look like magic, but for the general population, this is certainly true that any sufficiently advanced technology is indistinguishable from man. I'll give you a personal anecdote. When I watched my first television kind of mega series, which was Ramayana or Mahabharata, one of them. Many of the people in the front row will remember, none of you will probably have seen that. So that was the first pan-India thing that everybody at 9 a.m. on a Sunday would be glued to the TV, right? Streets would be empty, nobody's out on the streets, everybody is in front of the TV. My grandma was alive at that time. My grandma used to watch, and whenever she sat in front of it, because it's a religious kind of thing, she used to always put her like sari on top of her head. And we were like, why are you putting sari? Because she could not imagine that those people on the TV are not watching us. So she would be in her best dress to watch television. And we couldn't convince her until finally she saw us like putting our feet up and like pointing at the TV and watching. And then she realized maybe what her grandkid is saying is true, that those people cannot see us. So to her, it was magic that there was television, right? They had come from having basically radio all their life to suddenly seeing people staring at them and talking to them. So that was magic. So I think what we are also going to see in the next 10, 15 years might look magic for a lot of people who are not in technology. People who are in technology would have known the history. So immersive XR. What is XR? XR is a combination of virtual reality, augmented reality, all those things. Basically feeling of reality where it is not. Now, there is a lot of work going on. For example, Facebook is doing a lot of work on virtual reality. They had started, then they kind of went away from it, and then they are again starting to work on that. Now, what are you going to use immersive XR for? Lot of different use cases. What would you use if you are given XR? What would you use it for? Any idea? Louder. Somebody say something. Any ideas? What would you use XR for? Learning purpose. Come on, students don't use anything for learning purpose. Don't tell me. Who? Okay. So yeah, learning purposes, true to some extent. You can do a lot of experimentations and all in a virtual reality setup. You can get haptic feedback on your hand so that you know that you're physically doing certain things, right? All of those kind of things, right? So learning purpose is true. Um, there can be mobile holograms. What is mobile holograms? The thing that I was explaining, that a hologram of me might be here talking about it, right? You might have speakers from all over the world. A Nobel laureate can give speeches to the entire world and not have to travel, right? So you can get really important people to speak. I am free, I can come by, but better people are not free. They cannot come everywhere, right? Because travel time is so expensive. So holograms are there. It's not just for talks and a lot of different things. You can have holograms of devices, equipments, um, digital replicas, right? So you can have digital replicas. You can have a like you want to work on a car. Automation engineers can work on cars and all. There are already startups which are doing things like that for our industrial section. Even in Bangalore, there are startups who are working on that. So you get a digital replica of, say, a lathe machine. I don't know if you know a lathe machine, of big machines, right? So you can get digital replicas. You can see how things work. It can be used by students. It can be used by professionals, to figure out efficiency, what might go wrong, things like that. Right? And of course, surgeries and things like that. Right? You could, even these days, you do remote surgery that can become even more realistic. Students during their MBBS could be taught about the surgeries without, and so they would all be equipped to do remote surgeries over there. However, there are challenges, right? I am down to my last 2 or 3 slides. There are challenges. Now we want to do this in the with the luxury of our smartphone devices, smartphones or tablets or whatever. Currently, our what should I say? Our future expectations are not keeping up with the abilities of our phone. So it is not, the network is going faster than the device can use it. So the network, for example, the device, for example, the mobile GPU capability is only around computing gigaflops per second is around 4,000 gigaflops per second expected by 2030. So that means your devices are not going to be able to do your hologram related stuff, right? Which has the requirement of at least twice that. So that means we need tremendous development in our devices. So people who are into kind of actually building devices, building your GPUs and things like that, chips and all, will have a huge role to play so that our devices are powerful enough while not literally burning a hole in our pockets as well as figuratively burning a hole in our pockets, right? Because if you want to put a huge GPU in our phone these days, it's just going to burn you, both money as well as physically. Right? So there are a lot of these kind of technologies that need to be developed. So we will have better implementation or at least like mandatory split computing, whereas you do stuff at places where you can do a particular stuff. You cannot do a heavy computation at your device. You offload it to a stronger device, and that's where the network comes into play. That you have this 0.1 millisecond delay, so you really do not care about it. Right? So that is the reason that you would have to have mandatorily everything has to be designed in a distributed or computing package with a lot of efficiency on using resources as and when required according to the capabilities as and when. As and when the device, you offload it to a stronger device, and that's when there are challenges. So this was challenges in the device section, then there are challenges in the transmission section as well, right? Even for just because I have said that we will get thousands Gbps by 2030 is not going to happen. So right now our petrol usage is kind of like this. 4G uses up to 6 gigahertz. 110 gigahertz, up to 110 gigahertz is used by 5 gig, and the 6 gig is supposed to use around 3000 gigahertz, right? So terahertz. Anybody knows what is the problem as we go higher in frequency? Anybody uses car radios? Have listened to audio in car? What's the difference? What kind of channels do you get in the car?
Radio, FM,
FM and
AM.
AM. What is the difference between the two? From your experience, nobody listens to AM, so you don't know. Huh? So it's not slow. I mean, it's a people. If somebody is singing or talking, right? So it's the same speed, right? So what is the difference that you see between AM and FM? AM has a long range. So once you leave Bangalore, you're not able to tune into any FM, right? So you are going into the AM category. Why? Because AM fundamentally uses lower frequency and it is amplitude modulation, so it can go for a long distance, but its quality is a little lower, right? But when you use FM, you can have higher quality, but you have to stay close to whoever is transmitting, right? What's the for people who are in electrical engineering and or are just interested, what is the difference between two bands of your FM? What is your favorite FM channel?
Red FM.
93.5. And if in your car you press the next, or I don't know if you have cars or not, but whatever, if you press the next, what's going to be the next channel? No, from 98 it can't just go to 94. That means you're preset it. Yeah, it's basically around point 0.2, right? 0.2 megahertz, right? 98.3, 98.5, 91. So that's where the channel, two channels, if you bring them closer, they will start interfering on it. If you have gone through Fourier transforms and all, right? Then the two channels are never like this. Channels are like a curve. And so if you bring them too close, then these two curves will match, and then you can't bring it too close. Then it's not distinguishable. So you can't make receivers which can understand. So that is the reason that it is point 0.2. So as you go higher and higher in the frequency, you become more point to point and line of sight. So very close, you can get very, very high bandwidth, but the moment you shift a little bit, gone. It's like immediately it will drop off, right? We at this point, so it's called severe path loss, right? And so we at this point do not have antennas or the beamforming technologies or the waveforms or even the network architecture to be able to handle the to the right of 110 gigahertz, right? At this time, we do not. Obviously, a lot of people are working on it. A lot of high-end research is happening to it, and we will get there. If not 3000 gigahertz, we'll reach 1000 gigahertz at some point soon. And current RF devices, the radio frequency devices, your receivers and transmitters cannot differentiate and detect signals at that frequency. Right? So there's a lot of work that is pending in the communication field. I think that's about it. These are the challenges. So you are in exciting times. So whatever you are studying is still very relevant, and none of this has anything to do directly with AI and ML, which is, I think, what you are most focused on. But AI and ML will play a big role in trying to solve problems, right? So I end by a great talk, a great saying by GB Shaw. The single biggest problem in communication is the illusion that it has taken place. So it has an actual very metaphorical meaning, but I think it's even true even for our communication industry that we keep on saying that we'll get there, but lot of challenges. And so we need people, students from all over the world, as well as researchers and all to pitch in. Many of the current researchers would have retired or passed away by the time these things happen. So it's up to you guys to make it happen. That's about it. Thank you. Any questions? Question?
So exactly that was the mobile company. And I do kind of on mobile aspect. And we just talk about how we are building an app in computer, which cannot be done by a big company.
Well, see the what you once you give people ubiquitous communication, right? Once you give people ubiquitous communication and high bandwidth reliable communication, what we end up doing with it, I don't think we can predict. Right now, I don't think we'll be able to predict that. Right? We have some ideas which are all extrapolations of current ideas. But I think there will be a lot of use cases where it will suddenly be like, oh, we can do, like somebody will come up with something we can, it's a step jump, right? Unfortunately, I don't think I can tell you that this will be a killer app in the later. I don't think I can.
Somewhere like what are we
What we're trying to do is instant connectivity. Since the dawn of human development, what we have been trying to do from communication point of view is to cut down the time for me to talk to you. Earlier, there was no telephony, so I had to actually have to travel, right? There was no postal system. There was no postal system. There was nothing like that. So people would have to actually travel, right? There are then came the postal system where okay, I don't need to travel just to send a message, right? I can send a person, right? Earlier there were people who used to run and carry letters, right? Even in India, all over the world, people there were pigeons used to communicate, right? All those kind of things. The entire purpose is to send a message from one endpoint to another endpoint with reliability, right? Then slowly telephony came, and then came the internet, and then internet kind of started. Initial internet worked on telephony, and then now telephony works on internet. Again, what we used to be able to do earlier in days, now we could do in say hours. Then we could do, and this communication, by the way, is not just your network communication. Your earlier there were horse carriages, and then we moved to vehicles and things like that, flights. Now even that is too long, right? These days we say, oh, we have to go to the US. It's a 24-hour flight. That's too long, right? We cannot even imagine to going to the US 100 years back. So now people want that. I don't want to travel. I just want this real feel that I'm talking to this class full of students without having to travel to anywhere. So that, but these are all extrapolative things. But I think we will have that horse to car analogy somewhere where suddenly there will be something, oh, we didn't even imagine, somebody came up with. So I think those things will come. I unfortunately am not visionary enough to tell you that definitely this is where you should put your money. Mars first. Oh, yesterday Musk said that we need 10 trips to build Mars, which is where we can live also. Other questions? So excited about mobile communication? Hopefully, or too worried that this is too difficult to solve? Okay, thank you.
Thank you, Dr. Saab, for that engaging talk. We would like to invite Dr. Gururaj Hachal to felicitate. We now move on to an exciting panel discussion on careers in industry and research. I would now like to invite Mr. Shivansh Gautam, Chair of the MITB ACM SIGI Student Chapter, to introduce the panelists and the moderator.
ठीक है भाई YouTube
Thank you, Mr. Nishan. Now move on to an exciting panel discussion on careers in industry and research. This session will explore emerging opportunities, industry trends, and research challenges in the fields of AI and mobile communication. Our esteemed panelists, with their diverse experience in academia, industry, and research, will share valuable insights to help students and professionals navigate their career paths. Now, I'd like to invite Dr. Renuka Singhatta, moderator for today's panel discussion, to preside over the session. Dr. Renuka Singhatta, Senior Technical Staff Member and Manager, IBM Research Bengaluru. Dr. Renuka is a seasoned researcher and technical leader with a strong background in AI, machine learning, and software engineering research. He has worked extensively on intelligent automation, enterprise AI solutions, and software analytics, contributing significantly to IBM's global research initiatives. With years of experience in leading AI-driven innovations in enterprise applications, Dr. Renuka has played a key role in developing cutting-edge solutions for large-scale organizations. He has numerous publications in top-tier conferences and continues to mentor young researchers and professionals in AI and software engineering. I'm delighted to introduce. Thank you, ma'am. I'm delighted to introduce our distinguished panelists, Dr. Anbumani, Chief Architect, IBM India Software Labs. He is a leading expert in cloud computing, AI-driven automation, and enterprise software architecture. As Chief Architect at IBM India Software Labs, he has been instrumental in designing and implementing next-generation cloud-native solutions for businesses worldwide. With a deep understanding of enterprise technology, AI integration, and digital transformation, he has guided many organizations in their adoption of AI and cloud strategies. His vast industries experiences will provide us with valuable insights to industry trends, career growth, and evolving role of AI in enterprise and applications. Thank you for joining us, sir. Dr. Prashant Mishra, Senior Scientist, TCS Bengaluru, and ACM Distinguished Speaker. Dr. Mishra is a renowned researcher in wireless communication. Uh, I welcome you on the stage, sir. Thank you. Dr. Gururaj Mitchell, ACM India eminent speaker and faculty sponsor of MITB ACM student chapter. Welcome, sir. We can begin with the panel discussion. Thank you.
So welcome everyone to this panel discussion where we'll talk about industry and careers. And if you've just gone through, you have a real distinguished panel with cumulative years of experience is really immense. So what we'll do is the format will be, we'll start with the discussion where I'll just moderate, but we'll leave about 15 minutes for you all to ask any questions you will have. And you see the topic is really broad. So that will help you have any of your queries answered by this panel. So I'll start with the uh, fairly generic question, and I'll request each of y'all to go through your career journey and where you could talk about the important decisions
Put it
that
on
you
Instagram
took in
story.
your life, which helped you grow your path. And I'll just like to refer to this connecting the dots. So if you, I mean, what I mean is, if you've heard, there was this very famous talk by Steve Jobs where he addressed Stanford, and what he said was, when you take various decisions in your life, you may not be able to know what it does at that point in time, but when you go into the future, you'll be able to connect them, saying that these decisions helped me go where I am. So with that, I'll probably start with each of you. I'll start with Anbu. Maybe you can talk about all the decisions you took and how your career.
Thanks a lot, Dr. Renuka. So it's my pleasure to actually address this crowd. So I have about 28 up to 29 years of experience in IT. I'm actually from electronics and communications background in my BTech. I did MTech in software systems and PhD in actually business process analysis. So really wide variety. I did my BTech in 1992 in the past, like previous millennium, right? But I did my MTech 15 years later. I did my PhD 25 years later. My first job, actually, I was selected as pilot officer in Indian Air Force. And I also got an opportunity to join one of the IT companies. In my infinite wisdom, I chose an IT company, which was, my parents and everybody were really unhappy about. I was in core into computing right off the bat. I was actually looking after the Unix operating system internals and taking care of the TCP/IP stack. People used to dream of this job. I hated my job. I couldn't figure out the, day in, day out, looking at bits and bytes was not my cup of tea. After about 2 years of trying, I figured out that that's not my cup of tea. I need to expand further. That's when Euro as a currency was launched in Europe, and I got an opportunity to travel and work in Europe as part of my company. That opened up my opportunity into what I am today. And over the next 15 years, I actually ended up with middleware technologies, which was enabling, what we now call as e-commerce in Amazon and Flipkart. All of that basis was what I actually could invest in. But come 2020, after COVID, again I had to reinvent. So what I had to look at was AI was getting, in an explosive growth, and I needed to reinvent again. And I did my, invested in my PhD, and also currently I lead in IBM a particular product that focuses on application of AI for automating all your business processes. So if you go and open an account,
in any of the service provider, how can AI actually augment humans in making that happen? For that, I needed understanding of AI and a layer below what we are typically used to, right? Download a model, go ahead and do a quick fine tuning and use it. You needed a little bit more than that. You needed to actually understand what are the strengths and the weaknesses of AI. So to me, the career journey is more driven by a combination of what I would call as what the industry and the market is growing towards, my passion, and where I believe I could contribute. Every time, it doesn't mean that I left behind what I learned. Because I knew Unix in and out, I could understand middleware as a technology and all e-commerce, how it worked. Because I understood the industrial aspect of it, I could actually look at AI as more a tool that we need to fit in various ways we need to fine tune rather than accepting AI at its face value. So I was able to build on each other. What I typically say is when you are starting a career, of course, there is a buzzword today that everybody is interested in AI. Right? You wake up anybody from sleep and say, what do you want to do? They'll say, I want to do AI. What is AI? Something in AI, right? That's how we all think. But the journey is much longer. Have the patience to actually invest in it, and you would see the path will be every step that you take, the path will be revealed. And there is no, right or wrong choice at the beginning of your career. And I am a living proof of that. So that's what I would share.
And how about you, Prashant?
So, speak a bit about what I would say. So the underpinning probably I would relate to my uni studies a lot. Because if I had not invested explored too much at that point of time, I would have landed up in trade. So I probably take it to what I did with and how that actually shaped my career path over here. For a very so from a very early semesters of the UG, very interested to figure out, just like many of us here in the room, what is the future of tech. And at that point of time, there were two things I got very keenly interested in. I was a student of computing. However, I got interested into interesting streams. One was the VLSI stream, which typically in the early 2000s was not a very popular stream. There used to be work going on, but a very different stream to work on. And secondly, another thing that I believe I was a little bit more comfortable with the cloud computing, which is optimization, right? So probably in my third year, I spent a lot of time doing learning VLSI, doing projects on it, and probably in my fourth year, I did a lot of work on optimization, especially network optimization. And from there onwards, essentially, rather than getting into a higher study straight away, I worked for a couple of years because I wanted to build my aptitude as to what the industry problems are. I wanted to also get trained in industry problems. And I think that was a very good decision for me because that is where my love for system research developed. So we always just study in college in that, okay, we want to work on large scale systems. But if I had not landed up working on doing a full-time job for a couple of years, I wouldn't understand what that white elephant was. And that's when love of system research appeared. And it so happened that one thing led to another, and then I landed up doing my PhD with actually the co-inventor of Wi-Fi. Okay. And that was basically a career break for me completely because this guy was a physicist, but he was extremely good system researcher. Okay. And so at that point of time, I understood that you need to have a very good understanding of the foundational core engineering subject and also be a very good system researcher along with that. So both of these things are equally important. You cannot do good system research without knowing the science for it and vice versa. Okay, so that was a very big revelation for me. And I think that led to that. So I think that was my PhD, and then that led to my postdoc. My postdoc, I landed up essentially in operating system school. Okay. Now again, if you look at it, operating systems is also in some way it has a lot of work to do with system research. But again, operating research science and implementation is a bit more complicated indeed, and that's where I got exposed to it. And then from there, I think so if I look at my own career path, I look at it as self-network tree, wherein earlier in my career I focused on field level things in terms of trying to get my hands dirty, learning things up, picking up tough subjects, working on difficult problems, just to build my aptitude for and my scientific temper. And by scientific temper, I don't mean science. It's about probably the curiosity to ask questions, understand what if, why scenarios essentially well, try to get in the depth of the subject. So that helped me build my scientific temper a bit more. And I also gave myself a little bit time rather than rushing to things. For example, when I finished my UG studies, rather than getting to higher studies straight away, I took gave myself a bit more time, try to get a feel of how real world problems actually sound like, what are these large scale systems, work with people who actually understood or were very good at building such large scale systems, along with good scientific foundations, and that led to where I am today. I am the teacher of last around 9 years today. I do a lot of work on optimization, a lot of work on mobility, and so on and so forth. But what I actually learned in the UT, I think those foundations are just still I carry very strong with me. And in fact, that has actually helped me to maneuver across fields. So even if the technology changes, it's very not difficult for me to adopt a new technology because the fundamentals of math stats still remain with me, and for me it's to really adapt to actually any new stream that comes because as the fundamentals don't change, the semantics may change. The white elephant may get a little bit painted, maybe a little bit blacker, but it doesn't really matter. You can still understand that it's the white elephant and so on. So that's my learning over these years essentially. Thank you.
So if you see, we have Anbu from product research, product, Prashant from industry research. So now we'll get into the academic research.
Yeah, I'm totally from the different wing of umbrella as per you guys. Yeah, I completed my BTech, MTech, and PhD completely in computer science and without a break. As took a couple of years or some years of break. See, I think when Dr. Amit was dealing with the presentation, I was driving my, remembering my internship where I did my NSS simulator. Simulators were ruling like anything those days. NS2 is one of the simulator in 2010, 11, and also I have, which made me to try more on to computer networks, that to theoretical practice, not a system research. So, which make me to do immediately the P, no, doctoral work, So, where there was a part of internship program where I had to teach students also, where I was more focused on theoretical computer science, and which invites me to be a teacher. Even though I have a couple of offers from industry in my pockets, I would have not joined those because I might fascinate towards teaching, and also as a part of it, I can do research. I think nowadays it's not about different things as academy industry. They are amalgamated for the better journey of the students. Probably not for all, probably for few students because few people do their higher studies or they may do research. So that is where I main focus is on network security. Later on, I have worked couple of things on cyber security, and now I'm working on blockchain with collaborations at NBP National Blockchain Project at IIT Kanpur. This is where when I was doing my masters, that's a key point, or I can tell the connecting dots where I don't want to go for industry. I have to go for teaching and research. Yeah, this is a small journey where I have.
Maybe we'll start with you, Professor. So one of the things is, given that your career journey and you've taken on academic research and teaching, can you highlight some of the key skills that are required for somebody who would have to take up your career, like, follow your career path? What are the key skills?
Yeah, I think my main research interest right now is blockchain cybersecurity, and this I wanted to highlight something where we have there's no limitation for students to explore or learn. Okay, like we teach some cybersecurity attacks for the students or using some penetration testing or mobile penetration testing or whatever, and there should be some ethical practice they have to adapt, which is very important for every student. It's because the skill set what they develop. I have an incident where I used to tell the students of website penetration, where one of my student in my old university, he identified work in Scotland bank website, and where they have given a bug bounty for him, and later on he was acquitted by top-notch research cybersecurity wing. But what I'm telling is, it's all about how you develop the skill set. And I was telling him it's not ethical because you should not intervene in some other's website. As this is fair enough, but in the future. But what is it? So in India, we have right to educate, the right to learn. We can do whatever we want. We should not stop the exploration of the students. Yeah, you're right. But at the same time, we should have some ethics. Okay, because we used to tell the students to explore more, and at the same time, we should tell them to have the ethical practice also. Yeah, and adaptability is one of the major concerns which I tell because before some days cybersecurity was not a buzzword. Now cybersecurity is ruling like anything. Wherever it might be, it might be mobile penetration or web penetration or anything you talk about, or digital currency or whatever, there will be an attacks on cybersecurity. So I feel for the domain of cybersecurity and blockchain, I think the basic foundation subjects are very important. They have to develop the skill set of those, like learning computer networks in a greater level using some Linux operating system. I think that might be helpful for them. Along with that, nowadays I usually tell the students always don't lag behind the programming language because no code, nobody will ask you to write the code from the scratch of it. Okay, so you should understand the domain understanding, the foundation of it. So if you want to learn blockchain or cyber security, you should know computer networks, or it might be should learn a basic analysis of networks. I should not use ethical hackers. Okay, it's an oxymoron. We all know that. Usually, people will say about this. So I'm a very good ethical hacker. So ethics is something. This also we got when I was discussing at Cybersecurity Center of Excellence at ISD Bangalore in a meeting very much ethical hacking is an oxymoron where ethics you keep ethics and hacking. It's something which is totally opposite. So you learn, cyber analysis or how to attack, no, because if you want to be a cyber, expert or if you want to prevent, you should know how to attack. So that environment you can build, yeah, Kal Linux or any operating system you can take it. And these are some of the, aspects where I am dealing with, and these are the foundations what they can develop the skill set for their career in cybersecurity and blockchain.
Over to you, Prashant. What would you say are the key skills for an industry researcher?
So I think fundamentally, I think for research, whether it's academic research, industry research, I always think the very simple. It's good to have nothing time to have rubbish. I lived that at this point of time. I think, see, first of all, for doing research, fundamentally, coding is something. If you're not really good, you can also add, subject area, because when you are trying to do research, you know what has happened in the past, how you manage the present, and what is that's it. If you're not good in a subject topic, I don't think that will translate into a good research career. You have to be talented. From the talent, the other soft skills that you need. Right? The other soft skills that you need is basically the fire in the belly. Which means that they should be very difficult in getting things done, have to get things done. And to complement that, you need to be very, very disciplined. So the fire in the belly will only translate well if there's discipline with you and discipline translate consistent. So what I say that for becoming a good researcher, first of all, talent is must have. That there's no compromise of that. You should be good in your subject area. And to complement that, fire in the belly, determinism, being disciplined about things is very much required because that will ultimately help you push the boundaries because you never know what the outcome of research will be, whether it's successful or not. But you should at least know that I have a process of doing it, I'm methodical about it, I'm disciplined about it, and hopefully if I continue that process for a very long time, I will get something. That's what I think.
Right. So from a, if you're interested in joining an IT company, develop products, what would have helped? Right? But all the things that Dr. Gururaj and Dr. Prashant said, all matters. But additionally, the area is actually evolving so fast that how do you actually keep up with it? As Dr. Gururaj said, a programming language actually changes. Overnight, there is a new programming language. Overnight, new paradigms are coming. The AI and ML and the tools that you use, everything is coming. So your investment needs to be when they say it's in the fundamentals. What is that fundamental that you need to understand? When you grow in the career, the amount of information that you will have access to will also grow. Which means you need to choose between learning the syntax of a particular programming language versus learning the actual systems capabilities and its, real, behind the scenes, under the hood. what really happens. Also, when AI comes into picture, a lot of what we normally do goes away. Today, if I open my, PyCharm or VS Code, the number of key clicks that I need to do to type my Python function, let us say it is about 40, 50 lines of code, the number of times that I need to type tab to actually autofill is probably 50. Number of times I need to correct some of the code is probably 5 or 6, which means my skill of programming also evolves. So fundamental skill that we need to do is anticipate and prepare for the change. How do you anticipate? Like keep yourself abreast to what is evolving and so forth. And invest in some of the fundamentals. You need to know that every problem is probably a data in, data out problem. Every problem is a mapping problem, every problem. So your view of the world, you need to actually figure it out. It took me 2, 3 years for me to figure out how I would interpret the world and how I would start solving the questions. Each of you will have a different lens. That is also something. Right? Don't take Anbu's lens or Prashant's lens or Dr. Gururaj's lens. Each of you should have your own lens. So be open for change. Invest in your fundamental model of your world. And then, it's something that you can customize, you can borrow, but customize it. It is your own. With that in mind, if you invest in what I did is I invested in a combination of factors. I needed to understand the systems. Like if I want to look at an AI model, I needed to also understand what's the math behind it and how it actually runs in the systems components part of it. Which operating system? Where is it stored? Right? How is it accessed? What is the format in which it responds and what is the format in which I should request? All of these aspects is what sets you apart, which means you will continue to move up the value chain, right, and become more and more valuable. Even if machines take over the world, you will be managing those machines. That's what you should practice. Right? Thank you.
Before we move on to the next question, I just wanted to highlight this. I was listening to a talk by the founder of Netflix. Apparently, when he started his career, he went to his father. And his father gave him a list of things that he should imbibe in himself. And this has nothing to do with, the real fundamental skills. It was also saying that before you do all that, he just gave him things like be good, be, like have some determination, some very simple basic skills, or basic kind of characteristics that would make him successful. So what I'm saying is the fundamental skills, of course, you need to have, but also start imbibing other basic characteristics when you start your journey. And now I'll move on to Anu, because you mentioned you went on to, you took a break with your master's, then took another long break with your PhD. So I want to ask you, how important is this for the students today when they start their career, whether they pursue masters, whether they really go ahead, do their PhD, what do you think is required?
The industry is very, very brutal in how it assesses value of people. Right? There is a need, do you fit the need or not? And if there is a gap, whether that gap can be bridged and we put a band-aid on it, right? They're not even looking at fixing people for time. So preparedness for the industry is in one dimension. And your knowledge and your own passion and your pursuance of that is typically in an orthogonal line. Which means how you actually prepare, whether to do a master's or not, it should not be because the industry values the master. In my experience, it is because you are interested in furthering your knowledge and understanding. Through that, you will be able to provide better value to the industry, and hence, industry should value that. Not because I have a chapter, stamp that I am a doctor, means that anybody should automatically assume I'm an expert in it. Industry, through the lens with which it sees, is brutal in its assessment. The reality check we would get is we will be recruited as data scientists and we may need to be monitoring CACD dashboards, nothing more than that. So with that in mind, then when you're investing, it is going to be beneficial if you get an MTech because your understanding of the subject that you're interested in is going to get further. In a BTech, you're going to have more broader view. In an MTech, you're going to go deeper. When you go to the doctorate, you are probably forming hypotheses that you want to prove using the tools and furthering the science. If that's your interest, and through that you want to contribute to industry, phenomenal. Do the master's, pursue the PhD. For me, it took time to actually say that, you know what, my BTech is good enough. I believe that for 10 years, 15 years, before I realized that, you know what, my understanding is at a layer that if I need to go further, I need some theoretical concepts to do that. That is what drove my pursuance of content. So that's how I would also recommend each one of you look at it. Look at higher studies not as a ticket to a job, rather a ticket to furthering your understanding, which can be a ticket to it. That's what I would say.
This is what it was.
I echo with being a quite elephant. People don't know what to do with it. So in fact, so happy. Yeah. So, but right. Is this better? Now, however, I think, as Anbu said, I think the higher study, master's PhD, you should be doing it for yourself. Now, and I all encourage that each of you should do a PhD, okay, because it's a lifetime experience for each of you. The PhD is an experiential learning program, okay. While you are proving a hypothesis, while you're trying to advance science, you will discover a lot about yourself in that journey. To give an example, um, I got my first paper published when I was 2.5 years into my PhD program. Now I'll tell the reason for it. It was not that I was not making progress. The reason was the following. So we used to work, we were trying to prove a hypothesis, we were doing work, and we were getting results, we were writing the paper, and we were submitting to a venue. So my advisor, with whom I was working with, while it was okay when he was actually reading the paper and he used to give a go green to submit the paper, after a week again, he'll again reread the paper. And at that point of time, again, you figure out, oh, maybe this is not making sense, we should recall the paper. So I think I've recalled my first paper at least 3 to 4 times. Okay, and that can be very, very frustrating. So one fine day, actually, I really, I think I got really mad. 2 years on, I'm not getting any publication. The research company sitting on my head and asking me, where's the output? What's happening with you? So I said, essentially, and I typically took him on saying that this is not done, means you're delaying my entire progress and other things. So he told me one very fundamental thing which I still remember now. He said that, boss, writing a research paper is like putting a hand on Gita or Bible and swearing a courtroom that whatever I'll say is true but nothing but the truth. Okay. So if you believe that anything in your paper doesn't sound right, it is up to you to first, you should be the one who should be the first critic of it rather than the word. Okay. So that is the level. I think these are all these very interesting lessons that you have. Secondly, the amount of rejects that you get when you put a paper into a conference, okay, or in a journal. People are brutally honest with you. They may say that this doesn't make sense. You have to fix this thing, or we reject a paper. So you get a lot of rejections in life. Okay. So that actually builds your aptitude, your skill set, your personality. So that's why PhD is more than just a degree, it's an experiential learning program. While you are there to advance science, you also discover your limits as to what you are good at, what you are bad at. People will be really brutal with you. They can give a very nasty comment. They can be very good friends with you when you really do well. And find that side, and I believe that's how you actually become good in that subject area, and also you become good in many human skills that otherwise you would probably lack. So I think I encourage all of you to do a PhD, whether it's relevant for industry, not relevant for industry, is actually secondary. As I said, please do it for yourself. I all encourage all of you to do a PhD.
But that means you have to invest 5 years of your life. So, finally, Mr. Gururaj, one thing I wanted to ask is, what do you think are the pros and cons academic?
Yeah, for added to that, Dr. Prashant said, and I'll take 1 minute of that. If they wanted, I don't know about industry, as first and foremost in teaching, it's a mandate. Now we have a mandate for that. If they wanted to start their careers in teaching and research, PhD is a mandate. And apparently on the other side, before 15 years, 20 years before, research is only for PhD guys or something like that. But now it's not like that. Like anybody having their own innovation or skill set, they can innovate something and they can publish a paper. And nowadays, even it's mandate for UG and PG student to do some research articles before getting the award of degree or UG degree or PhD degree. No, postdoctoral degree. So yeah, right. And coming to your question right now. The pros and all the freedom to learn. They have an academics. There's no restriction, especially in we kind Maha say instead of eminence, we don't have students to have the curriculum fixed. They have to go with the syllabus and all. Apparently, we have to go with some topics, but we have freedom to learn. We can invite the students to explore and more, and that is one thought by different accounts. At the same time, yeah, they should whatever they have to learn or whatever they'll do, it should be ethical. If it is not ethical, I think to quote this recent past, no, the cyber attackers were the rank holders of BTECs at our some university. So the rank holders, they got gold medals in the degree of computer science. They are the hackers, and they did a lot of attacks. So what I mean is this kind of cons also will be there. So probably I can tell a lot of advantages when they go for learning stage. At the same time, there will be a lot of drawbacks like this. And yeah, and adaptability is very important. Down the line, as these guys already mentioned, programming skills, no, before 10 years before, it was like something like JavaScript and all. It was pretty fascinating, and everybody looking to JavaScript and they're going for the development of that vulnerability in those codes. But nowadays, people are looking at vulnerability in new languages like Ethereum or Solidity programming language, or it might be yeah, adaptability is one challenging things in students, or it might be for us as we are mentors, advisors for students. Adaptability for us also a challenging one. Yeah, that's all. I'll tell us pros and cons. Thank you.
Yeah, I mean, this, because I just had a short stint in academia also. I can say this, that the freedom you get to get deep into whatever you like is eventually there in academic research. And industry every 3 years, just 3 to 4 years maximum to try whatever you're doing and show business value. You can't, then you just move on. I mean, in my 15 years of experience in IBM research, if there have been times when we just had to get 6 months to close everything and more. So over to you, Krishna. What do you think are the pros and cons?
So again, I'll probably answer from two sides. I have spent some time in academia. I was teaching ISD. I am now in a from last 9 years. I've done my research. So I've seen both the good sides and bad sides of both things. The one is academic research. The good thing that yes, the freedom to do what you want, limitless. You can go complete blue sky. However, uh, time-bounded completion of work is a very big question mark because normally you're working with students. Students are so one time morning they're all pumped up and very excited. Next morning they're not excited. They will disappear for 2 weeks. Somebody's sick. So there is no regularity. So if I'm probably targeting something and I want to probably, I'm very excited to figure out what the outcome of this hypothesis is this thing working as a banking student. My experience is that you really cannot rely on me. You really need to be really involved in the work parallelly so that because these guys will disappear any morning. Okay. But then you have the freedom of taking a very tough problem, really go these guys in multiple new things. Now comes in the independent research. Now independent research, as Renuka was saying, you have a period of 5 years. Okay, and I think that's a good period because even in academy, even if you have the entire duration to do what you want, academics also change research topic every 5 years. Okay, so I think 3 to 5 years, 5 years is a good time frame for even independent researchers to work on something new because the technology is changing. However, here I can control the outcome. So if I tell my team that, boss, this is a conference, we're submitting this conference happening 9 months down the line, we better be ready with the results, we have to work this thing, they will pull out. Okay, because the price is on the line. Okay. If I tell them that I need to papers from here and these have to be paid from there, they will work towards it. Okay. And also I can control quality of the people coming in terms of the people being hired. So I have a lot of say on that. So what I'm saying that both sides have pluses and minuses. I think it is for you to decide what works for you. Maybe you are not ready to, you are not the guy who really love academic research because of the lot of uncertainty that may come with it, but you may like it because of the freedom that you get. On the industry research side, a lot of uncertainty, but if you get out something, you know that you have the resources to actually push and get things done. So you have to really choose your battles well, figure out what works for you, and as I said, both sides have plus and minus. It's complete up to you.
I think industry product development, most of you may already be aware of it because look for jobs. That's what you would see in advertisements in Indeed.com or LinkedIn or wherever else you're hunting for jobs. But just to summarize, right? Pros are obviously there is instant gratification that you get in industry work, right? Where you're implementing something and somebody is using it and somebody is getting the benefit of it, either money or outcomes and so forth. So that type of closeness to the final stakeholder where it really matters comes in the industry. And the other one is, of course, you get to, this is the happening place, right? Everything is visible. So you get to be part of a vibrant community. You can travel the world. You can, get dabble with various things. That's what it is current. It is in front of the stakeholders. You're able to contribute and get better. The cons is that industry uses you. How well do you use the industry to stay yourself, keep yourself abreast, keep yourself relevant is important, right? Don't, otherwise what will happen? Industry will just pigeonhole you into something that is a corner. And you may be recruited under a, nice banner, but then you go and start doing work. You can soon get into a cycle where you may become comfortable, but know that industry would actually chuck you out if you, sit in one place. So which means you need to understand that your role is not only to let industry use you, you should use the industry to actually. If you are not aware of it, you may become irrelevant or you may become part of this, side shows. Right? So that is the big con in the industrial career. You will get opportunities to learn, but you will have to learn it in your own time because during the work time, you need to do the work. You think that there will be 8 hours of work that you will do, you will be given 12 hours of work, which will be so difficult. Which means what is your time that you are going to spend there? While these two guys would work extra for passion, you will be asked to in an indirect way, there will be pressure that you need to stay in order. There are countries where people, when they leave, they need to apologize to others to leave. It's that bad. So the culture, time management, health management, and all of those, the work and life balance, it becomes work dominating everything else. So that's another con that I can think of. So if you have the self-awareness, obviously you can turn all of this into a pro and actually be successful. Some of us here are actually being able to. That's what I would say as a summary. Yeah.
Great. So now I'll just come to the last question and then we'll open it up for you. So one of the things is, there's so much of uncertainty, as you also mentioned. Every day there's some new technology coming, something new happening. For people who are starting their careers, what are they supposed to, how are they supposed to navigate?
So as I said, keeping abreast with the developments, right? You need to obviously learn. But The pace at which it is happening is it doesn't allow you to go deeper, right? So pick an area which resonates with you, and that resonance should come not because of a hype. You got something in your Instagram reel. That's a great way to get started, but you need to get into the next level of detail. So when things are changing in the world, you need to find something that is relatively stable. That is what should be your point of. For example, if it is AI, if you're investing yourself in either the Python library or the models themselves, these undergo the widest amount of change. What is next step? Okay, how do you actually, pre-process the data and make models work with the data? Like variety of data challenges, each problem it mentioned. What about the next level? What about the systems that enable each and every one of this moving data, running of these models? Some of these fundamentals do not change at all. So when you're starting your career, of course, pick the fancy, cherry on the top, but also identify what is the cream and the cake that you need to actually invest. And start with that, then you will get a little bit more leeway, right? When things are happening every month in the modern space, things probably happen, less frequently on the next phase. And then if you run down the systems evolution, you will get time to actually go further while you are still able to add value. So what I would say is pick the layer in which you want to go deep should have some sustainability. Pick that, find a good mentor, and then you will be able to set yourself. Last thing is, you don't beat yourself if your first choice is actually wrong. There is no wrong choices when you have a career. I'm a living proof. After 28 years, right, I have a comparison. I had two of my classmates from my 10th standard. We all went into engineering in various colleges, one in IIT, one in a normal second year college, another in a first year college. And then each of us had a career trajectory. Today, when I look at it, I'm a chief architect. The second person who actually had arrears in his college degree, but later on picked up, is actually a VP of product development in Land Rover in UK. And the third one actually runs a startup in India. And each of us took a path. Each of us had challenges at the start. One who came from IIT had the fastest, but we were able to reach eventually. So don't think that, oh, somebody who studied with me actually got a better placement today. Today it may be different. 5 years, it will be completely different. In 10 years, your trajectory will be. So play the long game. Don't get, short-sighted by what is in the current one. Somebody is having so much so, uh, you know, annual enumeration. That alone should be done. Invest in yourself because I hope you're going to live for 100 years with medical technology. You need to be relevant for 100 years, not just win the 100 meters sprint. That's it, I would say.
So everything what Anu said, I'll just request and keep these questions to mind in addition to what Anu said, right? Every morning when you get up, you ask yourself, will I hire myself? Always ask that first question. When you're brushing your teeth, you ask yourself, will I hire myself? Okay. So that will always inspire you to figure out what the lacunas are and develop yourself. And self-learning, everything that Anu said will become relevant. That is first part. Second thing is that you need to find a good work balance if you have to have a very long professional journey. Now, what is this work balance? So the first work is what the company is paying you for. And you do that because somebody is paying you for. But that may not be exactly what you want to do. Okay. So the second work is exactly what you want to do, what your passion is. Okay. So find that passion and invest time in that passion. So that way you'll be excited because you will do routine work as usual because somebody is paying you to do, but you will be also doing some work that is really close to your heart, which you are not getting paid for, but you really get very satisfied, or very a huge amount of satisfaction by doing that. Okay. And always make sure that you're not a frog in the well. You connect with the ecosystem. That's why professional bodies are very, very relevant there because that is where while self-learning will help you to build foundation, connecting with the larger community through professional bodies actually helps you grow and evolve over time. Okay, so if you want to have a very long-term career path, you want to be relevant for a very long time, you need to make sure that you connect with the large ecosystem, and nothing better than connecting with the large ecosystem rather than rather than connecting with a large professional organization and making sure you connect with mentors, talk to people, figure out what data is relevant, give back to the society, and figure out and you eventually have a long career span. These are
Yeah, they have said about the professional things like how tough the student should and they have to be. But I will put up the students as uncertainties comes and all. The student has to unleash and leverage themselves to attend these kind of events because you may feel that I think I'll tell you one instance in which when we have a deep stage the next day our director called me and said me that please arrange a workshop or talk or something for the students and all. As I said, it's not my area, I'll not do that and all. But why I'm telling this because this ACM chapter events or it might be as they rightly mentioned, talk to the mentors who are well versed with the technologies that might be not in par with the uncertainties, but at least they can be updated meaning every time.
Based on that.
That is one thing
Based
I
on
can
director.
tell. Like along with the, please stick to your mind to adaptability to the changes. That is one important part. And kindly please go and attend this kind of avenues where which you have a contacts, you have a networking sessions, so that you can imbibe extra knowledge apart from your academics. Okay, they are the things, the takeaways from this kind of avenues where you can, can able to be successful in the career. Yeah.
So thank you all. So, anyway, so this is open topic. Right now, like I'm also moving towards my fourth year and building up. Oh, and colleges are bringing up this rigorous training of giving us placement training with just Java, Java, Java. So I'm not understanding why is it that they want us to only go in that skill when actually I'm interested in AI and blockchain and trying to build there. And it's like they're scaring us that you don't have this skill, you don't have that. So what exactly is the gap for us to get in?
The gap is two sides. And the first gap is not you as a student. First gap is the industry's ability to assess the value of the student. Right? We have a tool. Okay. We have a tool called hammer. Every one of you look like a nail that we need to hammer it. Right? That's the problem. That is the first part of the problem. Second is part of the curriculum and how current student actually takes into picture. Right? If you look at Java as a technology, there is a syntax aspect of it and there is the actual, what the programming language stands for. The same concepts of object orientedness, memory management, thread management applies to Python, applies to JavaScript. So obviously industry needs to evolve to actually measure your capability so that programming language is not the lens through we measure, but the reality is we only have that one tool, right? You all look like nails. That's the, but at the same time, we encourage you to also make that jump where you're able to disassociate the fundamentals of the technology from the programming syntax that you need to also, right? And we will evolve, right? For example, some of the tests that IBM provides, we say you can go ahead and, refer to a manual. So if you know how to tackle a problem, you can look at the manual and come up with the solutions yourself. I think you should have the capability to do that. Tests are designed so that you will not be able to score 100% in many cases. Like top companies that will come to design tests that are hard because they are time bound and you will not have time to actually solve it. Which means you also need to do some prioritization. You also, so don't think that you are measured on Java alone. You are measured on your capability to apply a technology, think through the design of the problem in front of you, and realize it while managing your time, prioritizing on what you can and cannot do, and getting the maximum benefit of. These aspects you need to excel. And yes, you also need to understand the syntax of. So don't get disheartened. Yes, Java is a lens. And yes, you should learn it. Not because that is going to be how you're going to apply you. That's the job that you're going to work on. But reality also, if you look at the placement, records, look at the statistics of it. How many of us would end up as data scientists really working on the next generation of models where we have the generative, transformer models? What about the next generation of the model? If you look at it as a pyramid, right to the tip of the pyramid, it will be very, very few of us who will actually we should all aspire to it. That's how we will get to it. How many of us will be doing more consultative, service-oriented jobs in popular consulting companies? We would be the bottom of the pyramid as the majority. Where all of these tools matter, right? You are interested in VR, you are interested in AI. Unless you understand the tools and the systems that drives those layers, you will not be able to bring AI or VR into those areas. So you need so investing in this will enable you. So you can think of doing Java as the foundation that you are putting in, the water that you are pouring to your growing plant. You become a mighty tree, you can demand what you.
What about how AI is developing in companies? Because IBM, I see like when I try to apply for internships, they look for a particular AI intern role or an ML intern.
They do, but at the same time, when we are looking for an AI intern or a ML intern, we are not saying that did you do this particular model? It's usually, are you able to understand when you pick a AI model, what is the mechanics of your, end-to-end pipeline? Do you understand why you choose each step of that pipeline? And given a problem, so there is a how to do it. Every student with access to internet and ChatGPT can answer how to do it. What to use? The limited number of choices are there. Even if you don't know, there is a probability that 25% of the time you will actually answer correctly, the right tool for the right need. Correct? When to use what requires your thinking. That is what we would be measuring here. But the last, more critical, if you go to research, why have you chosen that particular? What are its pros and cons? What would work well, like what Krishna Suri was actually presenting, right? There are specific problems which will fail in the tools that you understand that? What are its boundaries? Why does it fail? If you are a research intern, you need to understand that why part of it. If you are looking at the how part of it, then you will get, more likely that we will not be successful.
Regarding the blockchain part. So is blockchain like when we talk about blockchain usually when I go to events also, it comes down to crypto, but then it's not down to crypto, it's also about cyber security. So where is the blockchain right now moving towards? Is it completely towards cyber security?
No, I think don't have a misconception between blockchain and cybersecurity. They're totally different. Blockchain, I think I wanted to mention this. Recently, I have attended one conclave at IIT Kanpur in collaboration with the University of Ulster, where they have implemented completely electronic health records with help of blockchain. And whether we can able to implement that electronic health records using blockchain in India, can we do that or not? That was a discussion for a 2 day long. It was an event, and a lot of medical experts and they all given the insights, and the end of the conclusion was we cannot able to implement in India because of n number of reasons. Why? Because it is purely decentralized. Decentralizing medical health records in India, it's practically not possible because of the logic behind how they make the money out of it and also. Yeah, it's going the right phase. For example, for your understanding, we have implemented blockchain for certificate generation. What are the events they used to conduct? All certificates will be given with an application of blockchain. They don't want to have it's verified by somebody else and all. So where you can attach that in any LinkedIn profiles and all. It's going for a smaller application. When we talk about no, for example, electronic voting machine can be implemented. Practically in India, it's not possible. So it's going in no, right way, but not for all the applications what can impose in India.
Good afternoon to all the panel members present here. Firstly, I'd like to thank you for the discussion. It was very insightful. And subsequently, I have like a couple of questions to each of you. So if I have the time, I'll go through them one by one. So, firstly, I feel like you put it very well.
Before you, I know you are between you and your lunch. So that's an incentive for probably nothing short of question. Let's make a difference in the. Yeah, actually, like,
I'll just ask one question then. So I feel like you put it very well when you mentioned something called work balance, in which you told something, spending time doing something you're paid for and spending time working on something you love. So I wanted to ask if you think it's sustainable to chase a job where it coincides, you're doing something that you're getting paid for, but also something that you love. So do you think it's sustainable to chase something like that?
I've been doing this the last 20 years. See, there is not 24 hours. We will always script that we will not have time for this, we will not have time for that. But you need to make time. If you want to get something done, you have to take time. You can crib about that. No, I have very long working hours. No, I get very tired. I do so many things. But in fact, if you're really passionate about doing something, you will figure out a way to do it. For example, I talk about in four things. And given that I have a working family is also time commitment, right? But I'm saying that I think you guys are at a better situation where you don't have real family. You're just looking at your studies or your going forward your job. So essentially what I'm saying is that you have to devote time, multiple things, and you'll find a model for it. So that's where prioritization becomes important. So it may so happen that in the entire 7 days a week, you may not give equal time to all the activities. But maybe the first 2 days a week you give time to the activity one day in the week activity, one day the activity, and that's when you and over time we'll probably develop also mental model that what works best. We'll talk about these things. But it's quite possible, and I think all of us are very examples of that. And you will see that more and more as become mature in doing both. And efficiency at doing things decrease. But you probably spend less time at doing things, but you will do things much more efficient manner. But it's really possible, and it's not rocket science. You just get that as you do more things.
Yes, sir. I get that you're saying it's possible to do both the things. My question was that is it sustainable to chase for a job in which both coincide? I.e., what you're working for and getting paid for is also something the thing that you love.
See, this is again, it's a very difficult thing. I don't see, for example, if I'm talking myself, I would probably say that the kind of work I do, so both my work and both parts are well balanced. So I really do think that I really enjoy it and I'm paid for that. I don't think you will get that mix in multiple places. So that's where I think when you take your call as to where you want to work for, or whom you want to work for, what kind of job, but you take this decision. It may so happen that there's a trade-off over there, wherein you may get really paid very high for things that you may not like, but you are getting very paid for. So is that a priority in life? You better do. However, if the priority in life is not money as work-life balance, you may want to prioritize other things for that matter. What I'm saying is that it's difficult to get the right combination all the time, but the combination do exist, but you will pay a price.
I have an associated point of view here. Um, if you remember, there is I think I forgot the name of the person who proposed this. So there are occasions where it will coincide. Is it worth waiting for that and preparing for that is your real question. I would say that don't lose sight of it. But at the same time, what you're currently doing is also important and you need to find joy in this. It should not be that you're miserable here with the hope of the future. Right? That if you're able to balance it out, what I have found is it takes, for example, for me to switch from a traditional to a more AI architecture, It took me about 4 to 5 years of investment. During that time, am I miserable? No, I know that I need to get there so that you keep moving. That is always possible. And the other thing is, yes, there is no one destination, right? You need to keep on evolving because the industry evolves, your interest evolves. So every 10 years, you may need to redo the journey. When you guys come in, every 5 years, you may need to redo. So, and hence, with your goalpost will keep on evolving. So keep that in mind. But as Prashant said, it's completely possible if you do time management. And yes, we have found our passions in the place where it pays also, and we are able to find the balance. That's it.
Thank you. And sorry for delaying everyone's lunch again, but just one more question in like the academia context. Sorry. Yeah, yeah. Yeah, so in the academia context, I just wanted to know, Gururaj sir, what you're most excited about in the technology landscape. We've seen crypto, we've seen AI, and now we're seeing quantum cryptography. I wanted to know what's the next thing that excites you the most? Is it the implementation of these technology, or is there another technology in the horizon that we haven't heard about
I think when we talk about the launch of this kind of technology, I think they are the right persons to tell about this because we used to empower the industry standards, but still, I cannot tell you like which technology will make you interested in this. Yeah, I think I don't have any heard of this name deepfake by chance? Yeah, I think might be we all lagging behind this in the sense this with social media, everything. I think more and more real-time deepfake it's my fascinating one where my face is called full-time scholars working on that also. Yeah, possibly that might be. I am excited to see real-time deepfake. Like we have a YouTube stream. I think even that can be a deepfake one, right? So those kind of things might be an exciting one. Right?
And that's a different topic. Okay. Take it a
Yeah, thank you.
Selfie with all of you also, right?
Registration is going on. Guys, there'll be a QR code after this for around 30 seconds where you guys can scan and fill the form for your attendance. Both my and non-my students can digital certificates will be provided to all the students for attendance. Digital certificates for the attendance.
So this is, we have a small token application from ESM India. Okay, we like to facilitate that. So first, Aksha. Thank you very much.
I again do not want to delay the lunch any further, but really appreciate the participation, the enthusiasm, all the questions, and the engagement that was going on in the panel and the talk. I do hope that the session was useful. It is one of the first industry days that we are starting off in this year. So any feedback, any comment that you have that would have made it more exciting, more engaging, please let us know. If we get enough good feedback, we'll come back again. Thank you. Please come forward for the group photograph. All attendees, please take your give this. Attendees, please come. Non-wise students, please stay back for a minute. We have small goodies from our side to give to all the non-wise students as a token of appreciation. There'll be a QR code shown. So for the registration, you can scan the QR code. Along with that, all ACM core committee members from all four chapters please come on stage for a group photograph with the giver.
Oh, Vishal, no. Attendance by Bhaskar. इसलिए ना इनको नहीं बोर्ड तो बोर्ड
No, no, here. Not here, they don't get it. Personal question.
What? Okay. ఇది ఇందాక నుంచి అడుక్కున్నాడు Women.